One such technique involves the use of prefabricated wall panels, which are manufactured off-site to exact specifications before being transported and swiftly assembled on-site. These panels often incorporate advanced insulation materials, such as high-density foam or recycled fibers, to enhance energy efficiency and thermal performance. Additionally, they may feature integrated structural elements, such as studs or reinforcement bars, further simplifying the assembly process. Another approach to quick and simple wall installation is the utilization of modular construction systems. In this method, wall components are fabricated in standardized modules that can be easily interconnected to form complete wall sections. This modular approach not only accelerates assembly, but also allows for greater flexibility in design and customization. Furthermore, advancements in construction adhesives and fastening technologies have contributed to the efficiency of wall installation. High-strength adhesives enable secure bonding between building materials, reducing the reliance on traditional mechanical fasteners and expediting assembly. Additionally, innovative fastening systems, such as interlocking mechanisms or snap-together connectors, facilitate rapid installation with minimal tools or specialized skills required. Beyond the construction phase, quick and simple wall installation techniques offer benefits throughout the lifespan of the building. The precise fabrication of wall components ensures tight tolerances and minimal waste, optimizing material usage and reducing environmental impact. Moreover, the efficient assembly process reduces labor costs and construction time, allowing zero-energy homes to be completed more quickly and cost-effectively. The traditional method of plastering internal joints involves applying multiple layers of plaster compound over joint tape or mesh to create a smooth and seamless surface. This technique requires skilled craftsmanship to achieve a flawless finish and typically involves sanding and priming before painting. While time-tested, it can be labor-intensive and time-consuming compared to newer, more efficient alternatives. Achieving a flat internal painted finish involves surface preparation to ensure a smooth substrate. This may include sanding imperfections, filling cracks or holes, and applying primer to promote paint adhesion. A consistent application technique is crucial to avoid visible brush or roller marks. Applying Dulux Acrytex quickly and seamlessly involves utilizing advanced painting techniques and specialized tools to ensure efficient and flawless coverage. First, the surface must be properly prepared, including cleaning, repairing any imperfections, and applying a suitable primer if necessary. Dulux Acrytex, known for its durability and weather resistance, is then applied using rollers, brushes, or sprayers, depending on the surface area and desired finish. Its advanced formulation allows for smooth application, minimizing drips, streaks, or brush marks. To ensure a seamless finish, painters must work efficiently, maintaining a wet edge and avoiding overlapping strokes. This helps to blend the paint evenly and prevent visible lap marks. In areas with intricate details or tight spaces, precision and attention to detail are essential to ensure complete coverage and uniformity. Firstly, the roofing system is designed to incorporate insulation materials directly within its structure, eliminating the need for separate insulation installation. This not only saves time but also ensures optimal thermal performance, reducing heat transfer and improving energy efficiency. Simultaneously, the ceiling components are integrated into the roofing system, providing a finished surface below the insulation layer. This prefabricated sealing eliminates the need for separate sealing installation, further reducing construction time and labor costs. During installation, the all-in-one roofing system is carefully positioned and secured in place, typically using specialized equipment and techniques. This ensures proper alignment and structural integrity, minimizing the risk of future issues such as leaks or structural failures. Pre-cut service ducts are precisely designed pathways within the structure, facilitating easy installation of electrical conduit for wiring systems. Quick and simple roof screw fix. Fascia flashings are prefabricated components that are easily fixed to the edge of the roof, providing a seamless attachment point for gutters, simplifying installation and ensuring proper drainage. Speedy installation of long-spanning insulated roof. Limitless flexible design options offer homeowners the freedom to customize their zero-energy homes according to their preferences and needs. From traditional architectural styles to modern innovations, the design possibilities are vast. Flexible layouts, diverse materials, and innovative technologies empower individuals to create unique living spaces that reflect their personality while meeting the highest standards of energy efficiency and sustainability. Installing rebar involves placing steel bars within concrete forms for structural reinforcement and stability. Tying rebar involves interconnecting steel bars with wire to ensure proper spacing and structural integrity. Preparing hole formers involves creating molds within concrete for fixtures, such as pipes or anchor bolts. Installing swift lifts entails positioning lifting anchors for hoisting heavy elements. Installing window blockouts involves placing structures to form window openings. Sealing door involves applying materials to prevent concrete seepage. Installing wire mesh in concrete construction involves laying sheets or rolls of steel mesh reinforcement within the concrete forms before pouring the concrete. The wire mesh serves to strengthen the concrete by providing tensile strength, which helps to prevent cracking and increase durability. It also helps to distribute loads more evenly throughout the concrete structure, reducing the risk of localized weaknesses. Additionally, the mesh helps to control shrinkage and cracking during the curing process. Proper installation of the wire mesh is crucial to ensure it is securely positioned and adequately supported within the concrete matrix. This reinforcement technique is commonly used in various construction projects, including sidewalks, driveways, foundations, and structural slabs. Initially, it includes clearing the site of any debris, vegetation, or obstructions. Then, grading and leveling the ground to establish a stable foundation. Utilities, such as water, electricity, and sewage lines, may need to be installed or rerouted. Finish smoothing the concrete is a crucial step in the construction process. Once the concrete has been poured and leveled, workers use tools such as trowels and floats to achieve a smooth and even surface. They carefully work the concrete to remove any imperfections, fill in low spots, and create a uniform finish. Wafflecrete insulated curing covers are specialized blankets or covers placed over freshly poured concrete to regulate temperature and moisture during the curing process, promoting proper hydration and strength development. Demolding is the process of removing the forms or molds used during the concrete pouring phase. It typically occurs once the concrete has sufficiently cured and gained enough strength to hold its shape independently. Demolding requires careful handling to avoid damaging the newly formed concrete surface. Workers may use tools such as pry bars, hammers, or vibrating equipment to loosen and remove the forms without disturbing the concrete. The demolding process reveals the finished concrete structure, allowing for further finishing touches or the commencement of subsequent construction phases. It marks a significant milestone in the construction timeline, signaling progress towards project completion. Laying the grade beams involves positioning and securing horizontal structural elements to support the weight of the building. Laying the floor panels entails installing precast or poured concrete panels onto the grade beams to form the base level of the building's flooring system, providing a sturdy foundation for further construction. Erecting the walls involves assembling vertical structural elements, such as precast concrete panels or masonry units, into the desired configuration. Workers carefully position each wall section, ensuring proper alignment and stability. Temporary bracing may be used to support the walls during assembly. Additionally, mortar or adhesive is applied to bond the individual components together securely. This process continues until all exterior and interior walls are erected, forming the basic framework of the building and delineating its internal spaces. Installing the columns involves positioning and securing vertical structural elements to support the building's framework. Laying the roof panels is a critical phase in construction where prefabricated or custom-made panels are positioned and secured atop the building's framework. Workers carefully align each panel, ensuring a tight fit and proper overlap to create a weather-tight seal. Fasteners such as screws or bolts are used to secure the panels to the supporting structure. Additionally, sealants or flashing may be applied at joints and edges to prevent water infiltration. This process continues until the entire roof surface is covered, providing protection from the elements. Installing eave trim panels involves affixing decorative or functional panels along roof edges. Foundations prepared, ICF blocks assembled, walls poured, and structure ready within 3 weeks. ICF blocks interlock effortlessly, resembling oversized Lego pieces, ensuring a snug fit without the need for adhesive. This simplifies assembly, enhances structural integrity, and expedites construction without compromising stability or insulation. Fittings strategically positioned within ICF walls during construction process. Uniform insulation layer throughout. ICF construction reduces thermal bridges by creating a continuous insulated envelope, mitigating heat loss and enhancing energy efficiency in buildings. Block weight only 2.5 kilograms, allowing for swift construction. An optimal team size of 2 to 3 individuals is ideal for ICF construction, ensuring efficient workflow and effective collaboration. With this small team, tasks such as block placement, concrete pouring, and reinforcement installation can be completed swiftly and accurately. This team size allows for better communication, coordination, and problem-solving on-site, facilitating a smoother construction process and timely project completion while minimizing labor costs. Window and door coverings are pre-fitted during ICF construction, ensuring precise alignment and facilitating smooth installation. This preparation includes framing, flashing, and sealing, streamlining the process for subsequent finishing work. Result: warm monolithic concrete foundation and walls. Excavation involves using machinery to dig up the driveway, creating a space for the snow melting system. The depth and width are determined by the system's specifications and the driveway's layout. Foundation preparation entails compacting the excavated area and possibly adding a layer of gravel to create a stable base for the snow melting system's installation. Sensor installation involves placing temperature and moisture sensors strategically across the driveway to detect environmental conditions. These sensors trigger the snow melting system to activate when snow or ice is detected. Insulation installation involves laying down a layer of insulating material beneath the heating cables to minimize heat loss and optimize efficiency. Snow melting cable installation comprises laying out the heating cables according to the predetermined design, typically in a serpentine pattern to evenly distribute heat. These cables are carefully positioned to cover the entire area of the driveway surface. During this step, the heating cables are embedded in sand and covered with another layer of sand to secure them in place. Pavement installation involves laying down the final surface material, such as concrete, asphalt, or pavers over the embedded heating system to complete the driveway. Securely fasten the push plow so that it aligns with the height of the curb for efficient operation. Prepare the area for the next curb installation by ensuring it is clear of debris and properly leveled. This ensures seamless placement and minimizes the need for adjustments, streamlining the overall process. By properly fixing the curbs, my efficiency in various tasks has improved significantly, with productivity gains ranging from 40% to 70%, depending on the specific nature of the job at hand. In the realm of construction, where time is often measured in weeks, months, or even years, the name Gruber has become synonymous with efficiency and speed. From the moment the project was initiated, Gruber's team of seasoned carpenters embarked on a mission to defy conventional timelines. Armed with meticulous planning and a wealth of experience, they set out to prove that quality construction need not be a protracted affair. The process began with careful groundwork and site preparation. Every detail, from the placement of the foundation to the alignment of the structural supports, was meticulously planned and executed with precision. Gruber's team understood that a strong foundation was essential to the longevity and stability of the structure, and they spared no effort in ensuring its integrity. With the groundwork complete, the carpenters wasted no time in erecting the skeleton of the villa. Utilizing cutting-edge techniques and state-of-the-art equipment, they worked in harmony to raise each floor with remarkable efficiency. Despite the complexity of the design, the team's seamless coordination and unwavering focus ensured that progress never faltered. As the villa began to take shape, attention turned to the finer details of construction. Skilled craftsmen meticulously crafted each component, from the intricate trim work to the sleek facade. Every element was thoughtfully considered, ensuring that the villa not only met but exceeded the expectations of its future occupants. What truly sets Gruber apart, however, is their unwavering commitment to timelines. While others may have balked at the idea of completing such a project in mere days, Gruber embraced the challenge with characteristic zeal. Their dedication to efficiency and precision meant that no task was too daunting, no deadline too ambitious. As the final touches were put in place, anticipation built among onlookers eager to witness the unveiling of Gruber's latest masterpiece. And true to form, the carpenters delivered with aplomb. In just a matter of days, what had once been an empty plot of land was transformed into a stunning testament to modern design and ingenuity. But perhaps the greatest testament to Gruber's success lies not in the completion of the villa itself, but in the satisfaction of those who call it home. For beyond the sleek lines and luxurious finishes lies a dwelling that was built not just with bricks and mortar, but with care, dedication, and an unwavering commitment to excellence.
Among the many structures along the route that required attention, Ford End Road Bridge, situated just south of Bedford's Central Station, played a crucial role in this ambitious project. This 19-span brick arch bridge carried Ford End Road over the Midland Main Line, and it became evident that the third span from the west needed a transformation to accommodate the new 25,000-volt overhead line equipment safely. The third span from the west was identified for removal and replacement with a modern bridge deck crafted from precast concrete units. This decision was pivotal to ensure that the electrification project proceeded without hindrance and with due consideration for the safety of passengers and the integrity of the railway system. Throughout the reconstruction process, an intricate web of monitoring equipment and track protection measures was meticulously employed to safeguard the surrounding railway infrastructure. The safety of workers and the continuity of railway operations were paramount at every stage. The removal of the third span from the west allowed for the installation of the new bridge deck constructed from precast concrete units. These modern components not only provided the necessary clearance for the overhead line equipment, but also guaranteed the bridge's longevity and structural soundness. In the subsequent stages, new parapets were seamlessly integrated into the bridge's structure. Crafted with an eye for design and aesthetics, these parapets were refaced in brick to harmonize with the rest of the original bridge, ensuring the preservation of its architectural integrity. The result was a reconstructed Ford End Road Bridge that seamlessly combined modern engineering with a nod to its historic roots.
Priming involves evenly rolling 0.2 kilograms per square meter of PU binder onto the cement base to enhance adhesion and surface preparation. For the base layer, mix SBR rubber and PU binder in an 8-to-1 weight ratio. This ensures proper cohesion and resilience, providing a solid foundation for the wet pour surfacing. Proper compaction of the SBR layer is crucial for achieving a stable and long-lasting surface. Ensure thorough compaction using a compactor machine to eliminate air gaps and achieve uniform density. This step enhances the surface's resilience, impact absorption, and overall durability, crucial for withstanding the rigors of playground use and ensuring the safety of children. Drawing the line according to the design involves planning and precision, ensuring that the layout accurately reflects the intended pattern or layout specified for the playground surface, enhancing its aesthetic appeal and functionality. The accuracy of drawing lines is paramount as it dictates the overall surface pattern of the playground. Precise lines ensure the correct placement of various elements, shapes, letters, or graphics within the wet-pour surfacing. This accuracy is vital for maintaining consistency and coherence in the design, minimizing visual discrepancies or irregularities that could detract from the aesthetic appeal or compromise safety. For the top layer, blend EPDM rubber and poo binder in a 6:1 weight ratio. This ensures a resilient and colorful surface with optimal durability and flexibility, essential for withstanding playground usage. Infilling the colorful EPDM rubber to the designated lines is a meticulous process that requires attention to detail. It involves carefully pouring or spreading the EPDM rubber mixture into the outlined areas on the playground surface, ensuring precise placement and alignment with the drawn lines. The goal is to achieve an even distribution of colors and a consistent thickness throughout the surface area. Proper infilling ensures that each color segment seamlessly transitions into the next, creating a visually appealing and cohesive pattern. Additionally, the EPDM rubber infill enhances the surface's impact absorption and slip resistance, contributing to the safety and comfort of children playing on the playground. Smooth and neat edges are essential to maintain the integrity and aesthetics of the surface design. Each color's edge must be meticulously attended to, ensuring a neat and smooth finish. This detail is vital for maintaining the integrity of the surface design and enhancing its overall aesthetic appeal. A smooth radius and horizontal surface are crucial for playground safety and accessibility. They minimize tripping hazards and ensure even distribution of weight, reducing the risk of injuries. Additionally, a smooth surface enhances the overall play experience, allowing children to move freely and comfortably across the playground. Covering EPDM rubber on vertical planes requires precision and expertise. After priming, allow a minimum of 3.4 hours for proper curing before covering the EPDM rubber to ensure optimal adhesion. Mix EPDM and poo binder thoroughly for 6 to 8 minutes, stirring regularly for 1 minute. Controlling the thickness between 6 to 10 millimeters is critical for ensuring the durability and safety of the wet-pour surface. A consistent thickness provides adequate cushioning and impact absorption, safeguarding against injuries during play. Thicker layers offer greater resilience and longevity, while thinner layers may compromise safety. Careful monitoring during installation ensures uniformity, preventing uneven surfaces that could pose tripping hazards. Adhering to the specified thickness range maintains the structural integrity of the surface, enhancing its ability to withstand heavy foot traffic and environmental factors for long-term usability. A smooth curved surface without abrupt changes in elevation minimizes trip hazards and ensures comfortable movement for children. Additionally, maintaining a horizontal plane prevents water pooling, promoting drainage and reducing the risk of slips. Painting the lines, letters, and patterns as per the design plan requires precision and attention to detail. Using high-quality, weather-resistant paint ensures longevity and visibility. Accurate application enhances the aesthetic appeal of the playground while delineating play areas and providing instructional cues. Following the design specifications meticulously ensures consistency and clarity, contributing to the overall safety and enjoyment of the playground experience.
The journey to creating a Bebo arch bridge commences with mold making. Once the design is finalized, steel molds are expertly crafted to replicate the desired shape and size of the arch. High-quality concrete is essential for constructing the Bebo arch bridge. The concrete mix is carefully formulated to achieve the required strength, durability, and workability. Reinforcing bars, commonly referred to as rebar, are strategically placed within the mold according to the project's specifications. These reinforcing rods add tensile strength to the concrete, ensuring that the arches can withstand expected loads without cracking or breaking. Once the precast arches have undergone quality control checks and are deemed fit for installation, they are packed with great care to protect them during transportation. A dedicated crane is employed to lift and position the precast concrete arches precisely. This method eliminates the need for temporary supports, making the assembly quick and efficient. As a result, construction time is reduced, and traffic flow in the vicinity of the bridge remains relatively undisturbed. One of the distinctive features of the Bebo arch system is its ability to eliminate the need for expansion joints in the road that runs over the arches. This design innovation results in a seamless and smooth surface for motorists, enhancing road safety and driving comfort. To ensure the longevity and durability of the structure, waterproofing and sealing measures may be implemented if necessary. Butyl rubber tape is inserted into the tapered edges of butt joints along the outer surface of the arches. External rubber sealing bands are then applied over the tape and adjoining concrete surfaces, with mastic used to adhere the bands securely to the concrete. This meticulous sealing process prevents water penetration and safeguards the arches from potential moisture-induced damage. Once the arches are securely in place and sealed, backfilling is conducted. The area around the arches is meticulously filled and compacted to provide additional support and stability. This step ensures that the arches can withstand the weight and pressures exerted by the road and traffic above, guaranteeing the safety and longevity of the Bebo arch bridge.
Curb roller, an innovative construction tool, revolutionizes the process of creating curbs, gutters, and other concrete structures. Developed to simplify and expedite these tasks, the curb roller eases the burden of manual labor and enhances precision in concrete shaping. At its core, the curb roller resembles a large heavy roller attached to a handle or control system. Its design allows for the shaping of concrete into various forms with ease. The roller comes in different sizes and shapes, enabling contractors to create custom curbs or gutters according to project specifications. One of its primary advantages is efficiency. Traditional methods of shaping concrete involve manual labor, requiring multiple workers to form, shape, and smoothen the concrete. The curb roller streamlines this process, significantly reducing the need for extensive manpower and expediting the completion of projects. Precision is another key aspect of the curb roller. Its design ensures consistent shapes and dimensions, leading to uniform and professional-looking results. This level of accuracy minimizes errors that often occur with manual concrete shaping, ensuring a higher quality finish. Moreover, the curb roller enhances safety on construction sites. By minimizing the need for excessive bending, lifting, and repetitive movements associated with manual concrete shaping, it reduces the risk of strain-related injuries among workers. The equipment's user-friendly design and intuitive controls also contribute to a safer working environment. Its versatility makes the curb roller a valuable asset in various construction projects. Whether for road construction, landscaping, or municipal infrastructure development, the tool's adaptability to different shapes and sizes of curbs or gutters makes it highly sought after in the industry. The adoption of the curb roller represents a shift towards more efficient and precise construction practices. Contractors and construction companies benefit from reduced labor costs, increased productivity, and improved project outcomes. Additionally, the tool's environmental impact is noteworthy, as it minimizes concrete wastage and enhances resource efficiency. The installation of a new underbridge along the primary Cork-Dublin rail line at Osborstown near Sallins in 2018 was a marvel of engineering precision and planning. Orchestrated by Iron Rod Éireann in collaboration with contractors, this ambitious project aimed to facilitate a road bypass under the rail line, enhancing connectivity and transportation in the area for Kildare County Council. The underbridge itself was a testament to careful preparation and strategic execution. Its construction was a culmination of months of dedicated effort, with contractors Sisk and Iron Rod Éireann fabricating sections of the underbridge alongside the rail line in preceding months. This prefabrication phase ensured that when the critical weekend arrived, the components were ready for assembly, minimizing disruption to the railway operations. The undertaking began in the wee hours of Good Friday in 2018, marking the commencement of a highly coordinated and precisely timed operation. At 0:30 hours, under the cover of darkness, the teams descended upon the site with purpose and determination. The first crucial steps involved preparation and clearance of the area around the rail line. Every movement, every piece of equipment positioned, and every worker's task was orchestrated with clockwork precision. With a flurry of activity that blended skill, experience, and expertise, the installation process unfolded. Each pre-constructed section of the underbridge was carefully maneuvered into place. Cranes, heavy machinery, and a symphony of labor seamlessly integrated their efforts to ensure the seamless integration of these prefabricated segments. The atmosphere buzzed with controlled urgency as workers collaborated in perfect synchrony. The alignment of each section demanded exactitude, leaving no room for error. Despite the complexity of the task at hand, the teams persisted with unwavering focus and determination. As dawn broke and the first rays of sunlight painted the sky, significant progress had been achieved. The underbridge was taking shape, emerging as a testament to human ingenuity and collaborative effort. The construction site, initially a canvas of raw materials and machinery, began to transform into a structural masterpiece. The clock ticked relentlessly as the teams relentlessly pursued their mission. Hours turned into a blur of ceaseless activity, marked by a blend of sweat, expertise, and unyielding dedication. The logistical ballet, orchestrated by Iron Rod Éireann and its contractors, reached its crescendo as the final pieces of the underbridge fell into place. By 10 o'clock hours on Easter Monday, an astonishing feat had been accomplished. The track, temporarily disrupted for the installation, was reinstated to its functional state. This rapid restoration of the railway network was a testament to the planning and seamless execution that characterized the entire operation. As the day progressed, the railway network resumed its vital function, connecting communities and facilitating transportation once again. By 12:30 hours, train services were back on track, heralding the successful completion of the underbridge installation. The endeavor, accomplished in the span of a single weekend, stood as a shining example of precision engineering, collaborative effort, and strategic planning. It showcased the capabilities of human ingenuity and determination in overcoming formidable challenges to achieve a shared goal of enhancing infrastructure and connectivity for the benefit of the community. Fabric installation in the chip seal process is a procedure designed to reinforce the pavement structure and enhance its durability. Before laying down the fabric, the roadway surface is thoroughly cleaned and prepared to ensure optimal adhesion. The fabric, typically made of polyester or fiberglass, is then rolled out onto the pavement and securely anchored in place. Special attention is given to overlapping seams to create a seamless barrier against water infiltration and to prevent any potential unraveling or shifting of the fabric. This step is crucial as it provides a strong foundation for the subsequent chip seal applications, maximizing the effectiveness of the pavement preservation process and extending the lifespan of the roadway infrastructure. During the chip seal first shot, a bituminous binder, usually emulsified asphalt, is applied evenly across the surface of the fabric-reinforced pavement. The binder acts as an adhesive, creating a strong bond between the fabric and the aggregate chips that will be laid on top. Specialized equipment is used to spray the binder in a controlled manner, ensuring uniform coverage and consistent application thickness. Once the binder is applied, aggregate chips are immediately spread over the surface, embedding into the binder to form a protective seal. During the chip seal second shot, another layer of bituminous binder is sprayed onto the surface, further enhancing the bond between the aggregate chips and the fabric-reinforced pavement. This additional layer of binder ensures thorough coverage and helps seal any gaps between the chips, providing additional protection against moisture infiltration and enhancing the pavement's durability and longevity. To construct the bridge offline, an extensive excavation process removed over 61,000 cubic meters of earth alongside the existing railway. This groundwork ensured a stable foundation for the subsequent construction phases, facilitating the creation of a robust structure for Britain's new high-speed railway. The 56-meter-long and 19-meter-wide structure is designed to accommodate Britain's new high-speed railway, facilitating its passage beneath the bustling existing railway line. In excess of 2,400 cubic meters of concrete has been poured in preparation for the bridge install. The intricate construction process of the bridge spanned 6 months, involving planning, fabrication, and assembly. This timeline underscores the complexity and precision required to ensure the bridge's integrity and functionality. HS2 is carrying out the UK's heaviest bridge drive of a concrete portal frame to install an intersection overbridge structure beneath the West Coast Main Line at Fulfen Wood near Lichfield. During the West Coast Main Line block, the team have removed the railway track and excavated over 15,000 cubic meters of material to create the space for the structure to be moved into. The massive 6,200-ton concrete structure will undergo a careful maneuvering process using self-propelled modular transporters. This method ensures precise placement and minimizes disruption to surrounding infrastructure during installation. 300 people working for HS2's civils contractor Balfour Beatty Vinci delivered the work, and a team of 200 people worked 24/7 during the blockade. 1,000 cubic meters of concrete was poured behind the abutment walls, prior to the technical backfill activity, to build up the embankment to TNE level for the existing railway. 10 robust curbs designed to contain derailed trains were lifted into position, demonstrating a high level of professionalism when working in close proximity to existing overhead line electrification. The 6 remaining precast parapets were stitched onto the deck, providing edge protection for the overbridge. 9 temporary props have been installed, to remain in position until the base slab is concreted and completed in situ. Following the bridge installation, the railway was restored to operational status, involving the laying of new tracks and the placement of 1,800 tons of top ballast around the sleepers. This comprehensive reinstatement ensured smooth railway operations. Step 1 involves carefully positioning the mold on a well-prepared flat surface, ensuring stability and levelness. This crucial step guarantees proper alignment and stability during the pouring process, resulting in a uniform and professional finish for the stone floor covering. Step 2 involves carefully pouring concrete into each section of the mold, ensuring even distribution and filling. Once poured, utilize a trowel to scrape off any excess concrete from the surface of the mold. For those desiring a smooth finish, employ a float to level and smooth the concrete surface, repeating the process until achieving the desired texture. This approach guarantees a professional-looking result. Furthermore, the flexibility of the mold allows for customization in arranging the sections according to preference. Whether creating a uniform pathway or incorporating artistic designs, the mold adapts to fulfill the envisioned outcome, offering versatility in landscaping projects. The concrete will set within 24 hours. To make the concrete stronger, regularly sprinkle water for 5 to 7 days. Do not leave the mold in the sun and rinse it clean with plenty of water. Once your project has dried, you can fill any gaps with sand or soil to enhance the appearance of the ground you've created. Clean off any excess with a brush. Creating your dream garden is now in your hands. With this mold, you can create custom walkways, pavements, etc., and add a more exotic atmosphere to your garden. Hydrofoam radiant heat insulation is a cutting-edge solution for efficiently insulating spaces while also accommodating radiant heating systems. Available in molded sheets with interlocking shiplap edges, these sheets come in dimensions of 4 feet by 4 feet or 1.219 by 1.219 meters, with thickness options of 2.5 inches, 64 millimeters, or 4 inches, 102 millimeters. This lightweight, high-density expanded polystyrene foam product is not only easy to handle, but also offers a high insulation value of up to R16 or RSI 2.82. One of the standout features of Hydrofoam is its 360-degree multi-directional friction fit anchor system, which eliminates the need for wire mesh during installation. This system allows for quick and easy placement of radiant heat piping in any direction required. To begin the installation process, it is essential to first level the ground within the structure to ensure a smooth surface. Starting from the left corner of the room, place a full sheet of Hydrofoam, ensuring proper interlocking for seamless installation. Removing the shoulder edge is recommended to ensure a snug fit against the wall. When starting subsequent rows, stagger the panels to create a stronger and more stable foundation. Once all the Hydrofoam boards are in place, the radiant heat piping can be installed effortlessly. Simply step the piping into the channels of the boards, utilizing the beveled edges for a secure friction fit. The stencils stamped in orange streets to denote the new high pedestrian activity area represent a significant step in enhancing pedestrian safety and accessibility within the CBD. Street Strong, a reputable crew tasked with this endeavor, meticulously applies a textured and colored asphalt surface at 14 strategic entrances to the CBD. These entrances, delineated by Paisley, Kite Hill, and Bing streets, serve as vital points of access to the bustling urban center. The process involves precision and attention to detail, as the crew ensures that the stamped patterns seamlessly integrate with the existing infrastructure while clearly demarcating the designated area for heightened pedestrian activity. The textured surface not only enhances visual distinction, but also provides tactile feedback for pedestrians, signaling the transition from vehicular-dominated spaces to pedestrian-friendly zones. Neglecting repairs can result in significant consequences, including damage to structures, vehicles navigating sunken slabs, trip hazards leading to potential lawsuits, and even the risk of sinkholes. When faced with the decision to repair sunken slabs, property owners typically have three options: slab replacement, mud jacking with cement grout, or leveling with polyurethane foam. Leveling the slab with polyurethane foam, such as Alchemy Spetex 2-component polymer foam, offers distinct advantages over traditional methods. This procedure involves drilling small holes and injecting high-strength polyurethane foam underneath the slab. As the foam expands, it lifts the slab back into place with impressive precision. Unlike mud jacking, which requires heavy equipment and can result in shrinking and cracking over time, polyurethane foam lifting is a cleaner, faster, and more cost-effective solution. The process is straightforward and minimally invasive. Crews drill 3/8-inch holes for injection, inject the foam, and watch as the slab gradually rises to its original position. Once the lifting is complete, crews finish the job by patching drill holes, sealing cracks and joints, and restoring the surface of the slab to optimal condition with silicone sealants. Cleanup is thorough, leaving the job site pristine. One of the most significant advantages of polyurethane foam lifting is its efficiency. Depending on the condition and size of the slab, the entire repair process can be completed in just a few hours. Unlike other methods that may require days of disruption and drying time, leveled concrete is typically ready for use within 45 minutes of completing the repair. Available in an assortment of forms such as lines, arrows, letters, numbers, and colored road signs, Preformed TCG not only serves practical purposes but also offers creative opportunities. Beyond traditional road markings, it encompasses a range of outdoor educational games for children, including mathematical, linguistic, logical, and animal-themed activities. One of the key advantages of Preformed TCG lies in its ease of application. With minimal equipment requirements, a simple propane burner, and trained personnel, it offers a cost-effective solution for road marking projects. Its straightforward installation process ensures efficiency without compromising on durability. Durability is a hallmark feature of Preformed TCG. Designed to withstand the rigors of high-traffic environments, it provides long-lasting visibility, contributing to enhanced safety for road users. Whether in bustling urban streets or expansive highways, Preformed TCG offers clear and reliable guidance, day or night, with its exceptional retroreflection capabilities. Moreover, Preformed TCG stands out for its customization options. Businesses can incorporate their logos, commercial symbols, or specific designs, tailoring road markings to their branding needs. This flexibility extends its application beyond traditional roadways, encompassing parking lots and various other environments, thereby contributing to improved traffic management and accident reduction efforts. Before the installation begins, the construction site undergoes thorough preparation to ensure that the dimensions of the recess align perfectly with the specifications of the shaft cover. Once verified, the installation process commences with the positioning of the adapter frame within the recess. The interior of the adapter frame is then sealed with damp sand to provide a stable foundation. With the adapter frame securely in place, shaft grouting mortar is applied to ensure a strong bond between the frame and the surrounding infrastructure. An adhesion promoter is also used to enhance the connection with the asphalt surface that will be laid subsequently. Prior to positioning the formwork, a release agent, typically a non-stick substance, is meticulously applied to the adapter frame's surface. This ensures that the formwork can be easily removed once the asphalt is laid, preventing any adhesion that could compromise the installation process. Once the release agent has been applied, the formwork is carefully positioned within the adapter frame, aligning precisely with the surrounding infrastructure. This step is crucial to ensure that the asphalt will be distributed evenly and compacted uniformly. Once the asphalt has been laid and compacted, an agent, often a specialized adhesive, is applied along with a bituminous strip. These materials serve to create a tight joint connection between the newly laid surface and the existing infrastructure, enhancing the overall integrity and longevity of the installation. This process ensures that the shaft cover is seamlessly integrated into the surrounding environment, ready to withstand the demands of everyday use. Once the asphalt is in place, the formwork is removed promptly to allow for the immediate insertion of the frame. The covers are then swiftly installed and closed, ensuring a snug fit. To further enhance the integration of the cover with the surrounding surface, the asphalt is leveled with the protruding frame edge and moistened before being vibrated to achieve optimal compaction. Functional checks are conducted to ensure that the installation meets quality standards. This includes verifying the smooth operation of the lid securing function and conducting any necessary adjustments to ensure proper functionality. On day 1, the team focused on removing the old asphalt surface and grading the area to prepare for the snow melting system. They also dug trenches for electrical conduits to carry power to the system, ensuring a smooth installation process. On day 2, the installation continued with the laying of layers on the prepared surface. Initially, a base layer of asphalt was applied and compacted using rollers. Following this, a binder coat was spread to create a smooth and even surface. The crucial step of laying the snow melt mats came next, with workers carefully positioning them according to the predetermined plan. A highboy was utilized to drop fresh asphalt on top of the mats, which were then manually covered before final compaction. This ensured the mats were securely embedded within the asphalt layers, ready for efficient snow melting operation. Day 3 saw significant progress in the electrical aspect of the installation. The team focused on assembling and installing junction boxes, which serve as key components for housing the electrical connections. These boxes were carefully positioned to facilitate easy access and organization of the wiring. Additionally, the installation of sensors was a crucial task undertaken on this day. These sensors, including over-temperature and precipitation sensors, were strategically placed to monitor environmental conditions and ensure efficient operation of the snow melting system. Attention to detail was paramount during this phase, with proper sealing and testing of all electrical components to guarantee safety and functionality. The integration of sensors marked a significant step towards automating the system's operation based on real-time weather conditions. Day 4 was dedicated to finalizing the sensor installation and ensuring their proper integration into the asphalt surface. After completing the final layer of asphalt, the team replaced the sensor housing cap with the sensors themselves. carefully adjusting their height to align with the surface. Grease and duct seal were applied to fill any gaps and ensure water resistance. Using fishing tape, the sensor wires were routed through conduits back to the control panel area. This process ensured that the sensors were securely installed and ready to provide accurate data for the snow melting system's operation. On day 5, the team focused on electrical connections, routing the power supply to junction boxes and making high and low voltage connections. Breaker boxes were installed, and connections were made at the control panel, ensuring seamless communication with relay panels. Sublot boasts several remarkable features that set it apart from conventional formwork solutions. Weighing only 2.5 kilograms, it eliminates the need for shoring or lifting equipment, making installation significantly easier and safer. Its foldable design and interlocking assembly mechanism enable swift implementation, with a single mason capable of installing an impressive 60 square meters per day, resulting in substantial time savings on construction sites. One of the most striking aspects of Sublot is its eco-friendliness. Manufactured from synthetic recycled materials, it offers a sustainable alternative to traditional formwork while maintaining the mechanical properties and durability of reinforced concrete. This environmentally conscious approach aligns with modern construction trends geared towards reducing carbon footprint and promoting sustainability. Furthermore, Sublot's design prioritizes worker safety by effectively preventing musculoskeletal disorders, MSDs, a prevalent concern in the construction industry. Its lightweight construction minimizes strain on workers, contributing to a healthier and more ergonomic work environment. The versatility of Sublot makes it suitable for various construction projects, including retaining walls, basements, technical rooms, waterproof basins, and exterior walls. Its compact size and ease of transportation allow for seamless deployment even in restricted spaces, such as noise barriers and fences. The construction process with Sublot is straightforward and efficient, beginning with the marking of the wall's location on the foundation, followed by drilling holes for vertical reinforcement. The blocks are then interlocked and secured. Horizontal and vertical reinforcement are added, ensuring structural integrity before concrete pouring. Once assembled, the wall undergoes rigorous checks for verticality, horizontality, and straightness before concrete sets. After a brief drying period, the upper rows can be added, completing the construction process. The end result is a reinforced concrete wall with all the desirable characteristics, including durability, environmental friendliness, and cost-effectiveness. Before any installation can begin, the playground area must be thoroughly prepared. This involves clearing the site of any existing surfacing materials, debris, and vegetation. The area is then leveled to ensure a smooth and even surface. The first layer of the wetpour system is the base course, typically consisting of 25 mm of SBR, styrene butadiene rubber granules. This base provides stability and impact absorption. To achieve proper drainage and prevent water accumulation, a layer of 100 mm of Mo Type 1 aggregate is laid and compacted. A geotextile layer is often placed on top of the aggregate to further enhance drainage and prevent the growth of weeds. The EPDM, ethylene propylene diene monomer, wearing course is the top layer of the wetpour system, providing the vibrant colors and texture of the surface. It typically consists of 15 mm of EPDM rubber granules mixed with a polyurethane binder. Mixing and pouring. The EPDM granules are mixed with the polyurethane binder in precise ratios to achieve the desired color and consistency. Once mixed, the mixture is poured onto the prepared base and spread evenly using a trowel or screed. This process requires skill and attention to detail to ensure a uniform thickness and seamless finish. Curing and finishing. After the EPDM wearing course is poured, it undergoes a curing process to allow the polyurethane binder to harden and bond with the rubber granules. This typically takes a few days, during which time the surface should be protected from foot traffic and adverse weather conditions. Once cured, the surface is inspected for any imperfections and touch-ups are made as needed. Jean Prouvé's response to the government order at the end of World War II marked a pivotal moment in architectural history, as he embarked on the design of temporary housing solutions to address the dire needs of displaced populations in Lorraine and Franche-Comté. The Ministry of Reconstruction and Town Planning provided specific guidelines, stipulating a floor area of initially 6 by 6 meters, 388 square feet, later expanded to 6 by 9 meters, 581 square feet, which Prouvé ingeniously partitioned into 3 immediately habitable rooms upon assembly. This innovative approach allowed displaced families to remain in place during the construction process, sparing them the additional hardship of relocation during an already tumultuous time. Prouvé temporary housing designs were not only pragmatic but also visionary. Intended for rapid assembly on sites where homes had been demolished by the ravages of war, these structures were engineered for flexibility, enabling disassembly and relocation if necessary. What set Prouvé's designs apart were their remarkable architectural achievements, achieved through the use of lightweight prefabricated components crafted from a combination of metal and wood. Given the constraints of the post-war era, with steel subject to strict quotas, Prouvé strategically allocated this resource primarily for the bent steel framework, a testament to his ingenuity in navigating the challenges of material scarcity. Standardized wooden panels seamlessly integrated into this framework, forming the walls of the dwellings, while the roofs were clad with bitumen-coated building paper, ensuring protection from the element. Jean Prouvé's 6x6 demountable house is an iconic example of mid-20th century modular architecture, celebrated for its ingenious design that prioritized functionality, portability, and adaptability. The house, originally conceived in the aftermath of World War II as a solution for housing shortages, has inspired architects and designers for decades with its innovative approach to prefabrication and transportable living spaces. Rogers Stirk Harbor Plus Partners, RSHP, took on the challenge of adapting Prouvé's classic design for contemporary living needs, while preserving its essence and spirit. Their adaptation is a testament to the timelessness and versatility of Prouvé's vision, demonstrating how modern technologies and design sensibilities can enhance and extend the utility of a historic architectural masterpiece. At the core of RSHP's adaptation is a deep respect for Prouvé's original plans. They have meticulously studied and honored the design principles that made the 6x6 demountable house revolutionary in its time. However, RSHP has also introduced thoughtful updates and additions to ensure that the house remains relevant and functional in today's context. One of the key modifications made by RSHP is the incorporation of modern living facilities, such as external bathroom and kitchen pods. By situating these pods on the exterior of the house, RSHP preserves the flexible internal layout of Prouvé's design, allowing occupants to customize the interior space according to their needs and preferences. Furthermore, RSHP has introduced a series of service trolleys that provide essential amenities like hot water and solar-powered electricity. This innovation not only enhances the self-sufficiency of the house, but also ensures that it can be deployed in diverse environments, from remote wilderness settings to urban neighborhoods. In addition to functional upgrades, RSHP has also introduced aesthetic enhancements, such as a glazed entrance and a new external decking platform. These features not only bring natural light into the main living space, but also extend the usable area of the house, blurring the boundaries between indoor and outdoor living. One of the most ingenious features of RSHP's adaptation is the innovative decking platform, which can be raised or lowered using a counterbalance system. This flexibility allows occupants to optimize their outdoor space while also providing protection against inclement weather conditions. One of the key features of Earthlock's approach is its customization. Recognizing that each embankment stabilization project is unique, Earthlock conducts thorough site assessments and engineering analyses to tailor solutions that best suit the specific conditions. By considering factors such as soil composition, water flow patterns, and environmental concerns, Earthlock designs embankment stabilization strategies that optimize stability and erosion prevention. Earthlock prioritizes environmentally friendly practices throughout its operations. By incorporating sustainable materials and minimizing the impact on the ecosystem, Earthlock ensures that its solutions are both effective and environmentally responsible. Choosing Earthlock for embankment stabilization needs not only ensures stability, but also contributes to a greener approach to erosion control. When it comes to slope stabilization, Earthlock is a trusted partner. Its comprehensive services provide effective erosion prevention and slope stability, ensuring the long-term integrity of banks and surrounding areas. Whether it's protecting against soil erosion, bank failures, or damage to nearby structures, Earthlock's tailored solutions offer reliable protection against erosion-related risks. Recognizing the importance of regular monitoring, Earthlock emphasizes the need for early identification of signs indicating the need for bank stabilization. Visible erosion, cracks, loss of vegetation cover, and increased turbidity in the water are all signs that prompt action. Addressing these signs promptly with Earthlock's solutions can prevent further damage, maintain slope stability, and protect against erosion-related risks. Earthlock approaches slope stabilization with a comprehensive strategy that involves thorough site assessment, tailored solutions, and the integration of various erosion control measures. By combining expertise in engineering, erosion control techniques, and innovative materials, Earthlock provides sustainable solutions that effectively mitigate erosion risks and promote long-term stability. In 1958, at the Bieri-Charanfon construction site, Bauer achieved a significant milestone in specialist foundation engineering with the invention of the ground anchor. This groundbreaking innovation revolutionized the approach to constructing construction pits and retaining walls. Instead of relying on obstructive strutting, these structures were now secured using ground anchors, presenting a considerable advantage for construction sites. Bauer emerged as a pioneer in anchor technology, employing specially developed equipment, tools, and processes for anchor construction. The process begins with excavating bores to predetermined lengths, employing various methods depending on soil conditions. These methods include drilling with or without casing, using single or double rods, and employing air or water flushing. An experienced team ensures smooth drilling of the anchors, maintaining precision and accuracy throughout the process. Bauer produces anchoring tendons with the required load capacity and length, catering to both temporary and permanent anchoring needs. These tendons are delivered to the construction site and prepared for installation using an anchor unrolling device, with labels ensuring proper placement. Operators control the cement paste supply remotely via radio, which is then pumped through hoses to the anchor drilling rig and into the bore before tendon insertion. Care is taken to preserve the integrity of the anchor bundle during installation, with the anchor unrolling device ensuring clean installation. Upon insertion, the inner rods are removed, and precautions are taken to prevent damage to the anchor bundle. When installed against pressing groundwater, the anchoring tendon is sealed against the retaining wall using a rubber hole packer. Post-grouting further stabilizes the anchor by pumping cement paste under pressure through a post-grouting pipe attached to the bundle. Once the cement paste has hardened, anchor heads are mounted, with Bauer offering customized solutions for connecting them to various retaining walls. Finally, the ground anchor undergoes testing and fixing using a stressing jack, ensuring it can withstand up to 1.5 times the service load. The attention to detail ensures optimum initial grouting of the anchor and the integrity of the installation process. Throughout the process, Bauer prioritizes quality and precision, ensuring that all work on the ground anchor is completed with the fitting of the anchor cap. In February 2020, a revolutionary project known as Build and Lift, Roof Lift, was unveiled, marking a significant milestone in the realm of construction technology. This groundbreaking initiative aimed to redefine traditional construction methods by leveraging innovative systems to reduce costs, time, and health and safety risks associated with building projects. The concept behind Build and Lift was simple, yet ingenious. Instead of constructing a building from the ground up, the project focused on lifting pre-assembled components, including entire roof structures, into place using advanced lifting mechanisms. This approach not only streamlined the construction process, but also eliminated many of the challenges typically encountered during traditional building methods. Imagine strolling past an empty field one morning, only to return later and find a nearly completed house standing where there was once nothing but the roof laid out. This scene encapsulates the transformative power of build and lift systems. By prefabricating building components off-site and then lifting them into place, construction crews were able to dramatically reduce the time required to erect structures. Moreover, the use of pre-assembled components minimized on-site labor and reduced the risk of accidents associated with traditional construction methods. This not only improved worker safety, but also contributed to overall project efficiency. Build and lift systems not only offered practical advantages, but also demonstrated a commitment to sustainability. By optimizing the construction process and minimizing material waste, the initiative aligned with broader efforts to promote environmentally friendly building practices. The successful implementation of the roof lift project in February 2020 served as a testament to the potential of build and lift systems to revolutionize the construction industry. As word of its success spread, anticipation grew for future projects that would continue to push the boundaries of innovation and redefine the way buildings are constructed. The accolade of being named the 2016 Outstanding Outdoor Track Facility of the Year by the American Sports Builders Association, ASBA, was no small feat, and it was earned by the pioneering efforts of Carpel, a leader in synthetic sports surfaces. Their installation of the high-performance Stobaton SW polyurethane surface at Gerard Filion High School in Longueuil, Quebec, Canada, marked a significant milestone in the realm of athletics track construction. This groundbreaking project not only showcased Carpel's expertise in synthetic sports surfaces, but also secured the first-ever IAAF Class 1 certification in North America for a Stobaton SW sandwich system running track. This certification underscored the track's exceptional quality and performance, setting a new standard for athletic facilities across the continent. Carpel's commitment to excellence extends beyond mere installation. Their comprehensive services encompass every aspect of track construction, from design and site preparation to drainage and surfacing. This holistic approach ensures that every project meets the highest standards of functionality and durability. The company's track record speaks volumes about their capabilities. Carpel's previous endeavors include supplying and installing the athletic tracks for the prestigious Toronto 2015 Pan Am Parapan Am Games. The success of this project was further validated when the main track at York Lions Stadium, the centerpiece of the Games, received a Distinguished Sports Facilities Award from the ASBA. The process begins with the unrolling of the geotextile fabric onto the conveyor belt, which transports it smoothly along the desired path. The system's precision ensures accurate placement of the fabric, eliminating the need for manual adjustments. Moreover, CRCPT can handle various types of geotextiles, adapting to specific project requirements. One of the primary advantages of CRCPT is its efficiency. By automating the placement process, CRCPT significantly reduces labor costs and project timelines. The consistent and uniform placement of geotextiles enhances the effectiveness of road stabilization and erosion control measures. Additionally, the system minimizes material wastage, optimizing resource utilization and promoting sustainability in road construction projects. Renowned for its versatility and meeting the highest standards, Billy True's REPHALT stands out. Its installation requires minimal equipment and can be effortlessly carried out by just one person, making it highly cost-effective. To ensure optimal adhesion, it's important to prepare the substrate by removing any loose particles and applying reactive primer where necessary. The environmentally friendly cold asphalt, available in convenient 25 kilo buckets or 14 kilo sacks, is applied and spread with ease, then quickly hardened with water. The installation of GBU soil cells along Talon's Pronksy Street marks a significant step towards urban greening and infrastructure enhancement. This project encompasses the establishment of 33 tree pits, accommodating a substantial volume of 520 cubic meters of soil. The primary objective of these soil cells is to reinforce the granular pavement foundations by introducing stabilizing forces within the earth structure, ensuring longevity and stability for the urban trees. The installation process involves several key steps to guarantee the efficacy of the soil cells. Initially, the assembly begins by joining upright panels, aligning them to form the desired structure for each tree pit. These panels serve as the framework upon which the soil cells will be built, providing essential support and containment for the soil volume. Subsequently, infill panels are carefully inserted into place to enhance lateral stability, ensuring that the soil within the cells remains securely contained. This step is crucial for mitigating potential shifting or displacement of soil, especially in urban environments subject to various environmental stressors. Furthermore, the installation includes the attachment of airflow lids, facilitating proper ventilation and airflow within the soil cells. Adequate aeration is essential for maintaining healthy soil conditions, promoting root development, and preventing waterlogging. To fortify the trees against external forces such as wind or storms, a secure arbor guy tree anchoring system is integrated into the installation. In Step 1, accurately measure the room to determine the required dimensions for the stretch ceiling. For example, measure the width and length of the room, such as 3.32 meters wide and 4.85 meters long. Order the stretch ceiling material with slightly larger dimensions, such as 3.52 meters wide and 5.05 meters long, to ensure proper coverage. Calculate the perimeter, which in this case is 16.34 meters, necessitating the use of 9 profiles for installation. In Step 2, cut the profiles to fit the dimensions of the room. Using the measurements obtained in Step 1, trim the profiles accordingly to ensure a precise fit along the perimeter. Use appropriate tools such as a miter saw or profile scissors to make clean and accurate cuts. Take care to maintain the correct angles, especially for corners, to ensure seamless installation of the stretch ceiling. Prepare the workspace. Clear the area around the perimeter of the room where the profiles will be installed. Ensure there are no obstacles that may hinder the attachment process. Position the profiles. Begin by positioning the first profile along one edge of the room, ensuring it is aligned straight and flush against the wall. Use a level to confirm that the profile is perfectly horizontal. Mark mounting points. Using a pencil or marker, mark the locations where screws will be inserted to secure the profile to the wall. Typically, screws should be placed at regular intervals along the length of the profile, approximately every 30 to 40 centimeters. Pre-drill holes. With the profile in place and the mounting points marked, use a drill to pre-drill holes at each marked location. Pre-drilling helps prevent the wall from cracking or splitting when the screws are inserted. Attach the profiles. Once the holes are pre-drilled, secure the profile to the wall using appropriate screws. Make sure to use screws that are long enough to penetrate both the profile and the wall securely. Use a screwdriver or a power drill to drive the screws into place. Repeat for each profile. Continue this process around the perimeter of the room, attaching each profile one by one. Take care to ensure that each profile is aligned correctly and securely attached to the wall. Address corners. When reaching corners, cut the profiles at a 45-degree angle to create clean and seamless joins. Secure the corner pieces in place using screws, ensuring they are diidly fitted together to maintain structural integrity. In Step 4, screw in the substructures to provide additional support for the stretch ceiling. Using appropriate screws, attach the substructures securely to the profiles previously installed along the perimeter of the room. Ensure the substructures are evenly spaced and aligned properly to evenly distribute the weight of the stretch ceiling and maintain structural integrity. Prepare the area. Clear the floor space beneath the stretch ceiling installation area to provide ample room for maneuvering. Gather assistance. Enlist the help of at least one other person to assist with lifting the stretch ceiling. This ensures safety and helps distribute the weight evenly. Start at a corner. Begin lifting the stretch ceiling from one corner of the room. Use caution to avoid tearing or stretching the material excessively. Gradual lifting. Lift the stretch ceiling slowly and steadily, keeping it taut as you work your way along the perimeter of the room. Avoid abrupt movements that could cause the material to rip or become misaligned. Check alignment. Periodically stop to check the alignment of the stretch ceiling and ensure it is being lifted evenly. Adjust as necessary to maintain a smooth and uniform appearance. Coordinate with installation. Coordinate the lifting process with the installation of the stretch ceiling to ensure a seamless transition. Communicate effectively with your installation team to synchronize your efforts. Position the stretch ceiling. Start at one corner of the room and position the stretch ceiling material over the installed profiles. Ensure there is a slight overhang to allow for trimming later. Align and smooth. Work with your team to align the stretch ceiling evenly along the perimeter. Smooth out any wrinkles or folds in the material to ensure a clean and uniform appearance. Begin stapling. Starting from the corner where the stretch ceiling was lifted, use a staple gun to secure the material to the profile. Place staples at regular intervals, approximately every 10 to 15 centimeters, to ensure even tension. Work along the perimeter. Continue stapling the stretch ceiling along the entire perimeter of the room, moving from one corner to the next. Pull the material taut as you go to prevent sagging or creasing. Overlap corners. When reaching corners, overlap the stretch ceiling material to ensure a seamless transition. Secure the overlapped sections with additional staples for added strength. Check tension. Periodically check the tension of the stretch ceiling as you staple, ensuring it remains uniformly taut across the entire surface. Trim excess. Once the stretch ceiling is securely stapled in place, trim any excess material along the edges using a sharp utility knife. Take care to make clean and precise cuts for a professional finish. Prepare the spackle. Mix the spackle or joint compound according to the manufacturer's instructions until it reaches a smooth and workable consistency. Apply the spackle. Using a wide putty knife or spackling tool, spread a thin layer of spackle over any seams, joints, or imperfections in the stretch ceiling material. Work in small sections, smoothing the spackle evenly as you go. Blend and feather edges. Blend the spackle into the surrounding areas of the stretch ceiling to create a seamless transition. Feather the edges of the spackle to ensure a smooth finish that seamlessly integrates with the rest of the ceiling. Allow to dry. Allow the spackle to dry completely according to the manufacturer's instructions. This typically takes several hours, but may vary depending on the type of spackle used and environmental conditions. Sand and repeat. Once the spackle is dry, lightly sand the surface to smooth out any rough spots or ridges. If necessary, apply additional coats of spackle and repeat the sanding process until the surface is smooth and uniform. Assess the excess. Begin by assessing the areas of the stretch ceiling where excess material protrudes beyond the desired edges. These areas may include corners, edges, or any sections where the material was intentionally left longer during installation. Mark the cutting line. Use a pencil or marker to mark a cutting line along the desired edge of the stretch ceiling. Take precise measurements and ensure the line is straight to achieve a professional finish. Prepare cutting tools. Gather the necessary cutting tools, such as a sharp utility knife or scissors, to trim the excess material. Ensure the cutting tool is clean and sharp to make smooth and accurate cuts. Cut along the marked line. Carefully cut along the marked cutting line using steady and controlled movements. Take your time to avoid jagged edges or uneven cuts. Trim corners and edges. Pay special attention to corners and edges, where precise cutting is essential for a seamless finish. Use caution to make clean and accurate cuts, ensuring the stretch ceiling fits snugly against the wall or other surfaces. Dispose of excess material. Collect the trimmed excess material and dispose of it properly. Keep the workspace clean and tidy to facilitate the final stages of the installation process. In Step 9, installing spotlights involves cutting holes in the stretch ceiling material at designated locations. Using a sharp knife, carefully cut holes where the spotlights will be placed. Then, insert and secure the spotlights in the holes, ensuring they are properly aligned and securely fastened. The process begins by removing the old surface layer to prepare the foundation for the new track. Subsequently, a layer of bitumen is spread over the track's surface, followed by the application of a primer using a roller, enhancing adhesion between the base and the upcoming surface layer. In a carefully controlled process, recycled tire granulate and a polymer binding agent are precisely blended in a mixer, ensuring thorough incorporation and uniform distribution, resulting in a homogeneous mixture crucial for the durability and performance of the track surface. The prepared synthetic binding agent mixture is applied onto the previously laid bitumen surface layer, ensuring comprehensive coverage. Finishing allows for tapping out a smooth and uniform surface layer. Its movement speed is very slow because it requires absolute precision. Human touch rules regarding finishing touches are adjusted to the nearest millimeter. Manual smoothing allows for connecting the joints between two halves of the track and ensuring harmony in the finish of the edges. Using a roller levels the surface for finishing touches. Upon complete drying of the surface, attention is directed towards marking out lanes and applying specialized paint for delineation. This process involves precise measurements and markings to ensure accurate lane alignment and proper identification for athletes. The layout is executed to meet regulatory standards and optimize the track's functionality and safety for competitive and recreational use. Stage 1 shredding involves the initial processing of whole tires to break them down into smaller, more manageable pieces. This stage is crucial as it sets the foundation for subsequent processing steps in tire recycling. The process begins with whole tires being fed into a primary shredder. such as the CM shredder mentioned. This shredder contains a patented knife system designed specifically for cutting tires cleanly and efficiently. As the tires are fed into the shredder, they undergo a rough shred, resulting in long strips or chips of rubber. The rough shredded pieces are typically too large for immediate use in end products such as tire-derived aggregate, TDA, or tire-derived fuel, TDF. Therefore, further processing is required to achieve the desired size and consistency. After the initial shredding pass, the shredded material is inspected to assess its size and quality. Any oversized pieces that did not undergo sufficient shredding are separated out and returned to the shredder for additional passes. This iterative process ensures that the resulting material meets the desired specifications for further processing. Additionally, during the shredding process, larger strips may remain on top of a classifier, while properly sized chips fall through to be discharged from the bottom. This classification step helps separate the material based on size, ensuring that only properly sized chips continue through the processing line. The shredded material may also be mixed with additional whole tires being fed into the shredder simultaneously. This continuous feeding process helps maintain a consistent flow of material through the shredder, maximizing efficiency and throughput. The process begins with the shredded tire material, from stage 1 being introduced to the CM Liberator, a specialized machine designed to liberate the steel wire from the rubber. The CM Liberator employs a series of mechanisms to effectively rip and pull the steel wires out of the rubber shred. Through this mechanical action, the steel wires are dislodged and separated from the rubber components. Once the steel liberation process is complete, the liberated material undergoes further processing to refine the rubber fraction. This involves reducing the shred size further and separating any remaining contaminants from the rubber, such as fiber and other inert materials. To achieve this, the material passes through a vibrating conveyor, which helps loosen the mix and facilitate separation. Subsequently, the material is subjected to a strong belt magnet that lifts the steel away from the rubber. The magnetic force attracts and separates the steel wires from the rubber, allowing for clean separation. After the steel removal process, the wire-free rubber is discharged and ready for resale or further processing. This rubber feedstock typically ranges in size from 1 3/4 down to -5/8 of an inch, depending on the specific requirements of end products. Moreover, any steel that may still have rubber attached is sent back to the Liberator for reprocessing, ensuring a zero-waste approach. This closed-loop system maximizes the efficiency of steel extraction while minimizing waste and optimizing resource utilization. The granulation process begins with the introduction of wire-free rubber feedstock into a granulator, such as the CM granulator mentioned. This machine is specifically designed to accept rubber material and process it into granulate of desired sizes. The granulator utilizes cutting blades or other mechanisms to further reduce the size of the rubber particles, resulting in granulate ranging from 25 mm down to 4 mm in size. During granulation, the rubber material may pass through multiple stages of screening to achieve the desired particle size distribution. Screens with different mesh sizes are employed to separate the rubber particles based on their dimensions. This allows for the production of granulate with uniform size specifications tailored to the requirements of specific end products. In parallel with granulation, fiber removal is carried out to extract any remaining fiber or inert materials from the rubber fraction. This is typically achieved using air systems and dust collection mechanisms integrated into the processing line. As the granulated rubber material moves through the system, airflow is utilized to capture and remove fiber particles, ensuring that the final product is free from contaminants. Additionally, vibratory fiber removal screens may be employed to further agitate the rubber material and aid in the separation of fiber particles. These screens help to dislodge and separate any remaining fiber from the rubber granulate, enhancing the purity and quality of the final product. The process begins with the introduction of rubber granulate into a dual-drive cracker mill, such as the one mentioned. This specialized milling machine features serrated hardened rolls positioned closely together to effectively crack and pulverize the rubber particles. As the rubber material passes between the rolls, it undergoes intense pressure and shearing forces, resulting in further size reduction and the formation of fine rubber powder. During milling, heat is generated as a byproduct of the mechanical grinding process. To prevent overheating and maintain optimal operating conditions, a chiller system is often employed to dissipate excess heat from the milling equipment. Following the milling process, the fine rubber powder is subjected to screening to achieve the desired mesh sizes. A gyrating screen system is commonly utilized for this purpose, featuring multiple screen decks with varying mesh sizes. The rubber powder is fed onto the screens, where it is sieved and separated based on particle size. The screens are designed to capture oversized particles and allow properly sized particles to pass through. This ensures that the resulting rubber powder meets precise size specifications required for specific end applications. The process begins with the procurement of raw materials, primarily rubber. This rubber can be sourced from both natural and synthetic sources. Once the rubber is obtained, it is mixed with various additives and fillers to achieve the desired properties such as flexibility, strength, and color. These additives may include carbon black, plasticizers, pigments, and other chemicals. The mixing process is usually done in large mixing machines or mills to ensure uniformity. In the molding stage of rubber tile manufacturing, the mixed rubber compound is transferred into molds to shape it into the desired form. This process requires precision and attention to detail to ensure consistent quality across all tiles. The molds themselves are crafted from durable metals, such as aluminum or steel, engineered to withstand the pressures and temperatures of the curing process. Once the molds are prepared, the rubber compound is poured or injected into them. In some cases, compression molding techniques are employed, where the rubber is placed into the mold cavity and compressed under high pressure to ensure proper filling and uniformity of the tile's surface. After the molds are filled, they are transferred to curing ovens or autoclaves where heat and pressure are applied. This heat promotes vulcanization, a chemical process that cross-links the rubber molecules, imparting strength and resilience to the material. The pressure ensures that the rubber takes the shape of the mold accurately and uniformly. Curing times and temperatures vary depending on the specific rubber compound and tile thickness. Once cured, the molds are opened and the newly formed rubber tiles are removed for further processing, such as trimming, finishing, and quality control checks. Curing is a critical step in the manufacturing process where the molded rubber tiles are subjected to heat to promote cross-linking of the rubber molecules, resulting in improved strength and durability. This step can take place in specialized curing ovens or autoclaves at controlled temperatures and pressures. Once the rubber tiles are cured, they undergo trimming to remove any excess material and achieve uniform dimensions. The tiles may also undergo surface treatments such as embossing or coating to enhance their appearance and performance. The East-West Gate Intermodal Terminal in Hungary spans 135,000 square meters of concrete road and boasts an additional 15,000 square meters of quartz flooring. This state-of-the-art facility was constructed between November 2021 and April 2022, serving as a pivotal point for intermodal transportation between Eastern and Western Europe. With its expansive surface area and modern infrastructure, the terminal facilitates seamless cargo movement, enhancing efficiency and connectivity in the region's logistics network. The Max Wind Hydro represents a groundbreaking advancement in the realm of pavement washing, being the first and only pavement washer in the world to be fully electrically powered. This innovative design is 100% electric, enabling its versatile use both indoors and outdoors, making it an ideal solution for estate management tasks such as cleaning pavements, decking, brickwork, signage, outdoor furniture, and more. Its electric nature not only aligns with zero-emission targets, but also offers significant advantages in noise reduction, facilitating late-night or early morning cleaning without disturbing nearby residents. One of the key features distinguishing the Max Wind Hydro is its deliberate exclusion of traditional hydraulic circuits, which often consume a considerable portion of a machine's power. This omission contributes to an impressive average runtime of 8 to 10 hours, allowing for uninterrupted cleaning sessions. Unlike older street cleaning carts that struggled with inclines and varied terrains, the self-driving Hydro is equipped to handle gradients of up to 20%, minimizing operator effort and enabling faster, more efficient cleaning. Thanks to its adjustable speed settings, the Hydro can maintain a comfortable walking pace, ensuring operators can work effectively without undue strain. Maneuverability is another highlight, with 2 fixed front wheels and large swiveling rear wheels providing exceptional stability and ease of steering across different floor types. Laying curbs can be a straightforward task with the right approach. Begin by ensuring you have the appropriate curbs, ideally ones that are lightweight, under 6 kilograms, for ease of handling. These should also be durable, ensuring longevity once laid. When cutting curbs to fit specific dimensions or angles, utilize either a disc cutter or a hand saw, depending on the complexity of the cuts required. The advantage of using these tools lies in their ability to cut curbs cleanly, without generating dust or debris, facilitating a cleaner and more efficient working environment. Ensure precise measurements and alignment during installation to achieve a professional finish. With these considerations in mind, laying curbs becomes a manageable and efficient task, resulting in a durable and aesthetically pleasing boundary for your project. Ensuring safe and accessible roadways is a paramount concern for urban planners and local authorities. In this pursuit, the implementation of new pedestrian crossings and road resurfacing projects emerges as a crucial strategy. These initiatives not only prioritize pedestrian safety, but also contribute to the overall enhancement of urban infrastructure. This article explores the significance of such endeavors and their impact on communities. Pedestrian crossings play a pivotal role in ensuring the safety of individuals traversing busy thoroughfares. By strategically placing these crossings at key points, such as near schools, parks, and commercial areas, authorities aim to mitigate the risk of accidents and promote pedestrian-friendly environments. The introduction of new pedestrian crossings often involves meticulous planning, considering factors like traffic flow, visibility, and pedestrian behavior. One of the primary objectives of installing new crossings is to facilitate safe passage for pedestrians, especially at intersections where vehicular traffic is dense. Features like zebra crossings, signal-controlled crossings, and pedestrian islands offer pedestrians clear demarcation and designated areas to cross, thereby reducing conflicts with vehicles. Moreover, incorporating accessibility features such as ramps and tactile indicators ensures inclusivity for individuals with disabilities, fostering a more equitable urban landscape. Beyond safety, new pedestrian crossings also contribute to the overall livability of communities. They encourage walking and cycling, promoting active transportation and reducing reliance on cars. Additionally, well-designed crossings can serve as focal points for community interaction, fostering social cohesion and a sense of belonging among residents. Road resurfacing is another vital aspect of urban maintenance aimed at enhancing both safety and comfort for road users. Over time, roads deteriorate due to factors like heavy traffic, inclement weather, and aging infrastructure. Cracks, potholes, and uneven surfaces not only pose hazards to motorists, but also contribute to increased vehicle maintenance costs and traffic congestion. Through road resurfacing projects, authorities address these challenges by restoring road surfaces to a smooth and durable condition. This involves the application of new asphalt or other suitable materials to repair surface damage and improve driving conditions. By investing in regular maintenance and resurfacing, cities can prolong the lifespan of road infrastructure and optimize transportation efficiency. Moreover, road resurfacing initiatives often incorporate sustainability principles, such as utilizing recycled materials and employing eco-friendly construction practices. This not only reduces environmental impact, but also aligns with broader efforts to promote sustainable urban development. The implementation of new pedestrian crossings and road resurfacing projects yields numerous benefits for communities. Firstly, it enhances safety for all road users, reducing the incidence of accidents and injuries. By prioritizing pedestrian safety, cities promote a more walkable and cyclist-friendly environment, which in turn contributes to public health and well-being. Furthermore, improved road infrastructure enhances the overall quality of transportation networks, facilitating smoother traffic flow and reducing travel times. This is particularly beneficial for commuters and businesses, as efficient transportation corridors support economic productivity and growth. Additionally, investments in pedestrian crossings and road resurfacing projects demonstrate a commitment to sustainable and inclusive urban development. By creating accessible, well-maintained infrastructure, cities promote equitable access to transportation and public spaces for all residents, regardless of age, ability, or socioeconomic status. In September 2009, the meticulous preparations for the renovation of the 70-year-old Stationsbrug in Middelburg commenced. Hollandia Services, commissioned by the province of Zeeland, initiated the process by strategically organizing the disassembly of the bridge. Employing specialized floating cranes with lifting capacities of 160 and 300 tons, they delicately dismantled the intricate structure piece by piece. With utmost care, the 280-ton bridge components were methodically removed and skillfully placed onto a pontoon, ensuring their safe transport to the designated renovation site. Every step was executed with precision and attention to detail, considering the historical significance and structural intricacies of the bridge. This phase marked the start of a comprehensive renovation endeavor that aimed to revive the iconic landmark to its former glory. Following the disassembly, The renovation process delved into a crucial phase of accurate measurement and thorough assessment. Load cells, specialized instruments designed for precision, were employed to meticulously gauge the exact weight of each section of the station's brug in Middelburg. This meticulous measurement was essential to ensure precise handling and restoration. Simultaneously, a comprehensive inspection took place, scrutinizing every component and surface for wear, structural integrity, and any signs of deterioration. This assessment aimed to delineate the required restoration work and ascertain the extent of refurbishment needed. The attention paid to this stage ensured that the subsequent renovation efforts were tailored to address the specific conditions and intricacies of the bridge, guaranteeing its long-term resilience and structural soundness. Over the course of an intensive 6-month period, the station's brug in Middelburg underwent an extensive and meticulous renovation, revitalizing its structure comprehensively. The transformation encompassed multifaceted tasks. The wooden deck was systematically replaced with a robust steel counterpart, ensuring enhanced durability and longevity. Simultaneously, the drive systems and intricate electrical installations were meticulously renewed, integrating state-of-the-art technology for optimal functionality. An aesthetically striking touch was added by adorning the bridge with a distinctive mint green hue, rejuvenating its visual appeal within the historical setting. Moreover, epoxy coatings were meticulously applied across surfaces, fortifying the structure against environmental elements and bolstering its resilience for years to come. The culmination of these endeavors resulted in a revitalized and fortified station's brug, blending modern functionality with historic charm. Amidst the station's brug's renovation, unforeseen hurdles emerged, notably the detection of chromate 6 within the layers of paint, demanding attention and specialized approaches. This discovery necessitated stringent protocols to safeguard against health and environmental risks. Expert containment measures were swiftly implemented, involving the setup of controlled environments for sandblasting to safely remove the hazardous substance. The careful removal process required precise handling techniques, ensuring the protection of workers and the surrounding environment. Addressing this unexpected challenge demanded innovative solutions and execution to mitigate risks and adhere to stringent safety standards, underscoring the project's commitment to not only restoring the bridge, but also ensuring the well-being of those involved and the preservation of the local ecosystem. Following the comprehensive renovation of the station's brug in Middelburg, the intricate process of reassembly unfolded with care and precision. Each section of the revitalized bridge underwent a systematic reinstallation, emphasizing the intricate nature of this restoration endeavor. The reassembly commenced with a detailed and strategic plan, organizing the placement of individual components to ensure seamless integration. Technicians and engineers worked methodically, carefully aligning and securing each section, acknowledging the bridge's historical significance and engineering intricacies. Concurrent with reassembly, exhaustive testing phases were initiated to verify the bridge's structural integrity and operational functionality. Rigorous inspections were conducted to evaluate the efficacy of the drive systems, electrical installations, and newly implemented components. These tests encompassed stress assessments, operational simulations, and functionality checks, aiming to validate the bridge's readiness for operational use. The attention to detail during reassembly ensured that every bolt, joint, and component was accurately positioned and securely fastened. calibration of intricate mechanisms, the rotational aspects and drive functionalities, underwent stringent verification to guarantee flawless performance. Simulated operational scenarios were meticulously tested, encompassing various load-bearing conditions and operational protocols, ensuring the bridge's seamless and efficient functionality. These tests were integral in identifying potential issues, enabling immediate corrective measures, and ensuring the bridge's compliance with safety and operational standards. Upon the completion of reassembly, meticulous finalization processes were initiated to ensure the bridge's seamless integration and operational readiness. The attention shifted to conducting comprehensive safety assessments and fine-tuning adjustments to guarantee optimal functionality. Highly trained technicians fine-tuned every aspect, verifying the alignment of components, ensuring structural stability, and conducting exhaustive safety checks. Integral to this phase was the installation and configuration of remote operation systems. These sophisticated systems were integrated to enable controlled bridge operation without manual intervention. This advanced technology allowed for remote monitoring and precise control, underscoring the commitment to modernizing operational capabilities while prioritizing safety and efficiency. The finalization phase assured the bridge's compliance with stringent safety standards and heralded its readiness for remote-controlled operation, ensuring enhanced safety and convenience for users. In Chile, the utilization of BAMTEC roll mats for reinforcing slabs has revolutionized construction practices. With over 200 tons of BAMTEC deployed, the efficiency gains are undeniable. Unlike conventional rebar methods, where workers struggle to install less than 250 kilograms per day per worker, BAMTEC boasts an impressive installation speed of 1 ton per worker hour. This remarkable increase in productivity not only accelerates construction timelines, but also significantly reduces labor costs. The ease of handling and installation of BAMTEC roll mats streamlines the reinforcement process, allowing construction teams to work swiftly and efficiently. Moreover, the superior structural integrity provided by BAMTEC ensures the durability and stability of the reinforced slabs, meeting stringent construction standards in Chile. This innovative solution not only enhances construction efficiency, but also contributes to the overall quality and safety of the built environment. As Chile continues to develop its infrastructure, the adoption of BAMTEC technology represents a significant advancement in construction methodology, offering a cost-effective and time-saving solution for reinforcing slabs. GeoHouse revolutionizes the construction industry by offering an innovative approach to building homes quickly and cost-effectively. At its core, GeoHouse utilizes a combination of Geoplast's products, Modulo, GeoPanel, and Joirney. These components work synergistically to create a streamlined construction process. GeoPanel serves as the foundation for the concrete walls, foundations, and columns of the house. Its durable and reusable nature ensures structural integrity while minimizing waste. Meanwhile, Modulo facilitates the construction of ventilated crawl spaces, enhancing the home's ventilation and moisture control. The beauty of GeoHouse lies in its modularity, allowing for the construction of houses in various sizes ranging from 50 SQM to 120 SQM, with the flexibility to accommodate custom dimensions as per the client's specific needs. At the forefront of this technological advancement is the Eindhoven University of Technology, 2E, where researchers and engineers have been pushing the boundaries of 3D concrete printing through innovative experiments and projects. Two notable experiments conducted at TUE exemplify the remarkable capabilities and implications of this cutting-edge technology. In one experiment, researchers at TUE explored the potential of 3D concrete printing for creating intricate and customizable architectural elements. Using a specialized 3D concrete printer, they meticulously deposited layers of concrete material, according to digital designs, resulting in intricately detailed structures that would have been challenging, if not impossible, to achieve through conventional construction methods. This level of precision and complexity opens up new possibilities for architects and designers to realize their visions with unprecedented freedom and creativity. Moreover, the efficiency and sustainability of 3D concrete printing were underscored in this experiment. By precisely controlling the amount of material used and minimizing waste, the researchers demonstrated the potential for significant reductions in material consumption and construction time compared to traditional methods. Additionally, the ability to use locally sourced materials and optimize designs for material efficiency further enhances the environmental sustainability of 3D concrete printing. In another experiment, 2E researchers explored the structural integrity and performance of 3D printed concrete elements. Through rigorous testing and analysis, they evaluated factors such as compressive strength, durability, and resistance to environmental factors. The results showcased the potential of 3D printed concrete structures to meet or even exceed the standards of conventional construction materials, paving the way for their widespread adoption in real-world applications. Furthermore, the experiment highlighted the versatility of 3D concrete printing in producing customized structural components tailored to specific requirements and constraints. Whether it's optimizing the geometry for load-bearing capacity or incorporating intricate patterns for aesthetic purposes, 3D concrete printing offers unparalleled flexibility in structural design and construction beyond the confines of the laboratory. These experiments hold profound implications for the future of construction. From enabling the rapid and cost-effective construction of housing and infrastructure to facilitating the realization of avant-garde architectural designs, 3D concrete printing has the potential to reshape the built environment in profound ways. Agricultural storage pits play a crucial role in modern farming operations, providing storage for various materials, such as grain, silage, or manure. These pits need to be durable, well-constructed, and properly finished to ensure longevity and functionality. True Concrete Solutions, based in Michigan, recently undertook the task of constructing a massive agricultural storage pit slab using their newly acquired Screed Saver Max machine, a remote-controlled laser-guided screed designed for high production rates and precision. Upon receiving the Screed Saver Max machine, True Concrete Solutions wasted no time in putting it to work. Led by Sean Richards and his dedicated crew of 7, they embarked on an ambitious project to place 1,400 yards of concrete over the course of 2 days, covering an impressive 75,000 square feet. Their proactive approach not only allowed them to complete the job swiftly, but also served as an intensive training exercise for their operators, ensuring they could maximize the machine's capabilities from the outset. The choice of the Screed Saver Max for this project proved to be apt, given the scale and complexity of the agricultural pit job. Unlike traditional screeding methods, the Screed Saver Max offered unparalleled power, precision, and high production rates, making it well-suited for handling large volumes of concrete efficiently. Equipped with a robust Kubota 35-horsepower diesel engine and a substantial screed head, the machine could effortlessly manage varying concrete slumps ranging from 3 to 6 inches, a feat that would have been challenging for conventional drive-in concrete machines. Moreover, the integration of Trimble LR30 laser eyes provided invaluable assistance in maintaining precise leveling across the expansive job site, even amidst heavy traffic. The remote-controlled operation, coupled with automatic functions such as memory downrigger placement, vibration, and laser leveling, simplified the training process for operators, enabling them to become fully operational in a matter of minutes. True Concrete Solutions' decision to augment the federal standard clay-lined pit with a concrete liner demonstrates their commitment to durability and longevity. By electing to add an additional layer of protection, they ensured that the pit could withstand the rigors of daily use, including the passage of heavy machinery, such as cat loaders, without compromising the integrity of the underlying clay liner. This strategic approach reflects their dedication to delivering high-quality workmanship that exceeds industry standards. The replacement of Dickinson's Creek Bridge heralds a transformative infrastructural upgrade, encompassing a 90-foot-long and 35.5-foot-wide concrete structure. It stands as a testament to modern engineering, poised to replace the aging predecessor in the same location. However, this endeavor is not merely a bridge replacement. It's a complex orchestration of multiple facets entwined in the larger web of development. The bridge's physical specifications are impressive, a testament to meticulous planning and design. But beyond its dimensions lie a cascade of logistical challenges and intricate alterations that render this project a symphony of construction and realignment. One of the pivotal components of this project involves the realignment of 4 adjacent canal bank roadways. This alteration is not isolated. It necessitates a domino effect of changes. An existing residence must yield to progress, making way for the evolution of transportation infrastructure. The widening of Dickinson Ferry Road to a substantial 32 feet over a length of about 600 feet on either side of the bridge is a substantial modification aimed at enhancing accessibility and traffic flow. To seamlessly integrate the new structure into its surroundings, both Dickinson Ferry Road and the adjacent Quinley Avenue intersection on the east side of the bridge will undergo a realignment. This is not just a matter of erecting a bridge, but of harmonizing the entire network of roads and intersections for optimal functionality and safety. The transition from the existing grade to the newly established elevation necessitates an import of substantial fill material. This act may seem rudimentary, but is a crucial step in ensuring a smooth and safe transition, prioritizing both functionality and aesthetics. However, the scope of this project extends beyond the realm of roads and bridges. The O'Donnell Lateral, an irrigation canal vital for the Merced Irrigation District, finds itself in the path of progress. Several hundred feet of this essential canal require relocation, highlighting the intricate balance between infrastructural development and preserving critical utilities. Moreover, the tendrils of change reach even further, infiltrating the agricultural landscape. The modifications to the irrigation system on the northwest corner of the project area are significant. It underscores the interconnectedness of seemingly disparate elements within a community. The bridge, roads, canals, and agricultural infrastructure, all entwined in a delicate dance of progress and adaptation. This project, with its multifaceted nature, epitomizes the complexity of modern infrastructure development. It's not merely the erection of a new bridge, but a holistic reconfiguration of the physical and logistical landscape. The synergy between engineering prowess, environmental consciousness, and community needs is evident in every facet of this undertaking. The process typically involves a carefully orchestrated sequence of steps. Firstly, the house is carefully prepared, which may include disconnecting utilities, bracing walls, and reinforcing the foundation. Hydraulic jacks are strategically placed beneath the structure, and the lifting begins. As the jacks exert pressure, the house gradually elevates, inch by inch, revealing the underlying foundation or allowing space for repairs or reinforcements. Throughout the time-lapse, viewers witness the seemingly impossible feat of a structure being lifted into the air with precision and control. Construction workers move around the site with purpose, orchestrating the operation with meticulous attention to detail. What might take days or weeks in real time is condensed into a captivating few minutes, showcasing the remarkable capabilities of modern construction techniques. Before beginning the installation process, it is essential to prepare the surface properly. Start by thoroughly cleaning the area where the stone carpet will be installed, removing any debris, dust, or existing flooring materials. Next, apply a primer to the prepared surface to improve adhesion and ensure proper bonding between the substrate and the stone carpet. Typically, this involves mixing the resin binder with the selected stone aggregate in the correct proportions. Use a mixing paddle and a suitable container to ensure thorough blending of the components. Before spreading the mixture, it's essential to ensure that the binder is properly mixed according to the manufacturer's instructions. This typically involves blending the resin binder with the selected stone aggregate in the correct proportions to achieve the desired consistency and strength. Once the mixture is prepared, it is poured onto the primed surface in manageable sections. Working in smaller sections allows for better control over the spreading process and helps ensure that the binder is applied uniformly. A trowel or a specialized spreading tool is used to spread the mixture evenly across the surface. The tool should be held at a consistent angle to ensure a consistent thickness of the stone carpet. Care should be taken to avoid leaving any gaps or uneven areas, as these can affect the final appearance and performance of the stone carpet. As the mixture is spread, it's important to work quickly to prevent it from drying out prematurely. This may require adjusting the working time based on factors such as temperature and humidity. Throughout the spreading process, periodic checks should be made to ensure that the binder is being spread at the desired thickness. Adjustments can be made as needed to achieve the desired result. Once the entire surface has been covered with the mixture, it may be necessary to go back over the area to smooth out any rough patches or uneven spots. This can be done using a trowel or a smoothing tool to ensure a seamless finish. The asphalt cutter stands as the initial weapon against compromised road surfaces. Its sharp blades slice through the asphalt, cleanly severing sections that have succumbed to settling. Precision is key here. The cutter allows workers to delineate the damaged area accurately, preparing it for subsequent repairs. This tool streamlines the process, making way for targeted fixes while minimizing disruption to unaffected road sections. Following the asphalt cutter's work, the frost heave remover steps in to address one of the root causes of asphalt damage: frost upheaval. As the name suggests, frost heave occurs when soil expands due to freezing temperatures, exerting pressure on the asphalt above and causing unevenness or cracks. The remover's function is to alleviate this pressure by extracting the affected soil or materials, mitigating the risk of further damage. By addressing the underlying issue, it paves the way for more lasting repairs. Once the damaged sections are delineated and the underlying issues addressed, the asphalt shovel takes center stage. It becomes the hands-on tool used to remove the broken or compromised asphalt. Its ergonomic design facilitates efficient removal without disturbing the surrounding area, ensuring a clean workspace for subsequent repairs. The shovel's versatility allows workers to navigate through various asphalt textures and densities, aiding in the extraction of damaged materials. These tools work in harmony, each playing a distinct role in the rehabilitation of settled asphalt. Their collective efficiency streamlines the repair process, reducing downtime for roads and minimizing disruptions to traffic flow. Moreover, their precision and functionality enable workers to address specific problem areas with accuracy, ensuring that repaired sections blend seamlessly with the existing road surface. Slurry seal is essentially an industrial-grade asphalt surfacing technique, applied as a cold mix paving system. Its versatility makes it a go-to solution for a myriad of problems plaguing various surfaces, from addressing minor cracks and fissures to rejuvenating worn-out surfaces. Slurry seal steps in as a reliable remedy. The composition of slurry seal is pivotal to its effectiveness. Aggregate, ranging from fine to coarse, forms the structural base, providing strength and durability to the pavement, combined with asphalt emulsion, a crucial binding agent, and fillers. This mixture undergoes a precise blending process. The addition of water aids in achieving the desired workability, ensuring a smooth application onto the surface. RoadSaver, a specialized machine designed for micro-surfacing and slurry seal applications, embodies innovation in pavement maintenance. This state-of-the-art equipment executes the intricate process with precision. Its functionality encompasses the accurate blending of materials, ensuring the optimal consistency required for a flawless application. With its advanced technology and calibrated systems, RoadSaver efficiently tackles the challenges of surface treatment. The process begins with preparation, where the surface is cleaned and any necessary repairs are undertaken. The RoadSaver machine then takes charge, precisely mixing the aggregate, asphalt emulsion, fillers, and water according to the specified formula. This meticulous process ensures the creation of a high-quality slurry mixture. Application of the slurry seal using the RoadSaver machine is a task, demanding expertise and finesse. The machine uniformly spreads the slurry mixture across the designated area, ensuring consistent coverage and a smooth finish. The sealed surface undergoes a curing period before being ready for traffic, ultimately presenting a rejuvenated, resilient, and durable pavement. Partnering closely with Cormac and Cornwall Council over the past several years, Velocity tailored this machine specifically to address Cornwall's unique road network. The county's exceptionally rural and tight roads posed immense difficulties for conventional repair vehicles, straining the network's maintenance. To combat this, the new 11-ton machine was engineered to precisely target these challenges, ensuring these vital routes remain open and safe for use. The machine's redesign focused on compliance with stringent emissions legislation, featuring a smaller engine for sustainability without compromising operational power. Efficiency was key. It boasts impressive repair figures, averaging over 26,000 repairs in a year. What's striking is the substantial cost savings, with repairs coming in under £18 per square meter compared to traditional methods costing over £65. Furthermore, the environmental impact is significantly reduced, with Velocity's repairs emitting nearly 10 times less carbon compared to conventional repairs. One of the standout capabilities of the 5700C was its adeptness in navigating confined spaces. Its compact design facilitated maneuverability in tight spots like parking lot corners, islands, and cul-de-sacs, enabling operators to access areas that were previously challenging with larger machines. Notably, its transport at legal width without the need for a lowboy trailer added to its convenience and efficiency on the job site. The machine's steering mechanism was a standout feature. While it simplified tight radius turns by utilizing the front track for steering, it also offered the option for all-crawler steering, providing flexibility for diverse applications. This adaptability catered to various job requirements, enhancing the machine's overall utility. A key component contributing to the efficiency of the 5700C was its high-torque auger conveyor. This conveyor facilitated faster concrete pouring by swiftly moving large volumes of concrete while maintaining a well-mixed consistency. Its ability to handle incline angles and hold substantial concrete volumes was particularly advantageous for radius and cul-de-sac work. Moreover, the machine's mold mount offered hydraulic movement, granting operators the flexibility to adjust the mold's position swiftly and precisely. This feature was invaluable when pouring in areas with obstacles like catch basins or uneven subgrades, providing enhanced versatility in challenging job site conditions. The carbide tooth trimmer embedded in the machine was another standout feature. Capable of handling tough subgrades, it minimized reliance on grading contractors. With the ability to hydraulically side shift and vertically adjust, this trimmer offered exceptional adaptability, allowing for precise trimming even in extreme conditions or when faced with obstructions on the job site. The SmartTamp control system integrated into the 5700C was a technological leap forward, providing operators with increased accuracy and control. This system's self-diagnostic capability and automatic sensor shutdown in case of deviation from the string line ensured precise and error-free operations. These joints are designed to accommodate the expansion and contraction of bridge components due to temperature fluctuations. They prevent the formation of cracks and damage that might occur if the structure were rigidly connected. Essentially, they act as a buffer, absorbing the forces generated by the movement of the bridge sections. One of the most common types of mechanical road joints used in bridges is the modular expansion joint. These joints consist of multiple steel beams or modules that are placed side by side. Each module has a gap between them, filled with an elastomeric material such as neoprene. This material possesses excellent elasticity, allowing it to stretch and compress while maintaining its structural integrity. Installation of these joints requires precision and careful planning. Engineers consider factors like the length of the bridge, expected traffic load, and environmental conditions to determine the type and size of the expansion joint needed. They also need to ensure that the joint's movement capability aligns with the bridge's expected expansion and contraction. Maintenance plays a crucial role in ensuring the effectiveness of mechanical road joints. Regular inspections are necessary to identify any signs of wear, tear, or damage. Damaged joints can compromise the bridge's safety and functionality, making it essential to address issues promptly. Cleaning and lubricating the joints are part of routine maintenance to prevent debris accumulation and ensure smooth movement. The importance of these joints becomes apparent when considering their role in ensuring the safety of the bridge and the vehicles using it. Without proper expansion joints, bridges could suffer structural damage due to temperature changes, leading to potential hazards for commuters and disrupting transportation networks. Moreover, these joints contribute significantly to the comfort of drivers and passengers. Imagine driving over a bridge with a rigid connection between segments. Every expansion and contraction due to temperature changes would cause noticeable bumps and vibrations. Mechanical road joints help minimize these disturbances, providing a smoother ride experience. Innovations in materials and design have improved the performance and durability of mechanical road joints. Engineers continually seek to enhance these joints to withstand heavier traffic loads, increased movement, and more extreme environmental conditions. They explore advanced materials that offer superior flexibility, durability, and resistance to wear and tear. Additionally, technological advancements allow for more efficient monitoring of bridge conditions, including the health of mechanical road joints. Sensors and monitoring systems can detect changes in the joint's behavior, indicating potential issues before they escalate. This proactive approach to maintenance helps in extending the lifespan of the joints and ensuring the bridge's safety. While mechanical road joints play a crucial role in bridge functionality, challenges still exist. Extreme weather conditions, heavy traffic, and aging infrastructure pose ongoing challenges for maintaining these joints. Engineers and researchers continually work on developing innovative solutions to address these challenges, aiming to create joints that require minimal maintenance and offer maximum durability. What distinguishes these spray ramps is their capability to handle a spectrum of common road construction binding agents. From bitumen emulsions to polymer and specialty bitumens compliant with ADR regulations, these ramps accommodate diverse materials pivotal in surface treatment processes. The remarkable feature is their operational range, allowing the processing of these binding agents at temperatures reaching a maximum of 225 degrees Celsius, ensuring versatility and adaptability in various construction settings. The emphasis lies not only in the technological advancements, but also in the practical application of these spray ramps. They streamline workflows, ensuring precision in the dosing of binding agents, essential for the enhancement and durability of surfaces. This precision ultimately translates into the impeccable quality of treated surfaces, meeting and surpassing industry standards.
The Cow Lane Rail Bridge Replacement Project in Reading was a significant infrastructure undertaking aimed at modernizing an essential transportation link in the town. This project, which was completed in recent years, marked a crucial milestone in the region's efforts to improve its railway infrastructure, enhance safety, and accommodate the growing demand for efficient rail services. The Cow Lane Rail Bridge, located in Reading, had been a vital crossing point for both road and rail traffic for many decades. However, over time, the old bridge had deteriorated significantly, and it no longer met the requirements of modern transportation needs. Its narrow width, limited weight-bearing capacity, and outdated design made it a bottleneck for both road and rail traffic. The project involved several key phases, including detailed design, demolition of the existing bridge, and construction of the new structure. The design phase considered modern engineering and safety standards, as well as the unique requirements of the Cow Lane area. The new bridge was designed to be wider, accommodating multiple lanes of traffic, and it was built to modern load-bearing standards to handle heavy vehicles. Additionally, the railway portion of the bridge was designed to accommodate the latest rail technologies, ensuring smoother and more efficient train operations. Demolishing the old bridge was a complex process, given its proximity to the rail tracks and the need to minimize disruption to both road and rail traffic. The demolition was carried out with precision and safety in mind, and the removal of the old bridge marked the beginning of a new era in the Cow Lane area. Construction of the new bridge was a remarkable engineering feat. Skilled workers and cutting-edge construction equipment were used to assemble the structure, ensuring that it met the highest safety and performance standards. The new Cow Lane Rail Bridge now stands as a testament to modern engineering and urban planning. The completion of the Cow Lane Rail Bridge replacement project brought numerous benefits to the Reading community. It improved traffic flow for both road and rail users, reducing congestion and enhancing safety. The new bridge also contributed to the overall modernization of the town's infrastructure, ensuring that it remains a vital transportation hub for years to come.
The Archimedean screw hydro turbine, at the heart of this system, is a relatively recent addition to the small-scale hydro industry, having gained prominence in the last decade. Originally designed by Archimedes around 250 BC, these screws were initially employed in Egypt for irrigation purposes. Over time, they have evolved into a pivotal component of hydropower systems, especially in sewage treatment plants, where thousands have been installed globally. The manufacturers dominating the pump market have transitioned to become key suppliers in the hydropower sector. The functioning principle of the Archimedean screw involves the reverse action of its historical use. Water enters the screw at the top, and the weight of the water propels the helical flights, causing the screw to rotate. This rotational energy can then be harnessed by an electrical generator connected to the screw's main shaft, resulting in the generation of electricity. Archimedean screws are particularly suited for low-head, high-flow sites, efficiently operating on heads as low as 1 meter. Single screws can handle heads up to 8 meters, while multiple screws are employed for heads exceeding this range. The screw's diameter determines the maximum flow rate, ranging from 1 meter to 5 meters, with flow rates from 250 liters per second to around 14.5 cubic meters per second. In terms of power output, Archimedean screws vary from producing as little as 5 kilowatts to as much as 500 kilowatts. The screws typically rotate at around 26 revolutions per minute, necessitating a gearbox to adjust the rotational speed to a range between 750 and 1,500 revolutions per minute for compatibility with standard generators. The distinctive feature of Archimedean screws is their debris tolerance. The large dimensions of the screw's flights and slow rotational speed allow relatively large debris to pass through without causing damage. This eliminates the need for fine screens at the intake, reducing debris buildup and negating the requirement for expensive automatic intake screen cleaners. Furthermore, Archimedean screw hydroturbines are known for their fish-friendly nature. The low rotational speed and large flow passage dimensions create a safe passage for fish downstream. The absence of draft tubes or discharge sumps simplifies civil engineering works and foundations, reducing construction costs. Noteworthy is the variable speed operation of high-quality Archimedean screws, enabling adjustment based on the available flow rate in the river. This enhances overall system efficiency and reduces noise during operation. With a design life of 30 years, these hydro turbines can undergo a major overhaul to extend their operational lifespan.
Smart Siphon is a groundbreaking innovation in the field of flood irrigation, specifically designed to revolutionize the way cotton farms manage their irrigation processes. This technology is heralded for its ability to automate flood irrigation, replacing traditional hand siphons with a smart, efficient system. Gate installation. Sensor-equipped gates are strategically placed at key points in the irrigation channels. These gates control the flow of water and can be adjusted remotely. Pipeline network. Underground pipes are laid out according to the farm's design, connecting the gates to the central control unit. This network ensures efficient water distribution. Central Control Unit, the heart of the Smart Siphon system, the Central Control Unit, is installed in a secure location. It is equipped with advanced software that monitors weather conditions, soil moisture, and water levels. Sensor integration. Sensors are installed at various points across the farm to collect real-time data on soil moisture, weather conditions, and water levels. This data is transmitted to the Central Control Unit. Configuration and testing. The system is configured to the farm's specific needs, ensuring precise irrigation scheduling. Rigorous testing is conducted to verify its functionality. End result: once Smart Siphon is fully operational, cotton farmers experience a range of benefits. Efficiency. The system automates the irrigation process, eliminating the need for manual labor with hand siphons. This significantly reduces labor costs and improves efficiency. Precision irrigation. Smart Siphon utilizes real-time data to schedule irrigation events, ensuring that cotton plants receive the right amount of water at the right time. This enhances crop health and yield. Water conservation. By closely monitoring soil moisture and weather conditions, Smart Siphon optimizes water usage, contributing to sustainable farming practices. Remote control. Farmers can remotely monitor and control the system through a user-friendly interface, making it easier to manage irrigation even when off-site.
Washington 4, Site Office and Steel Yard in Lantau Island. The construction process begins with the establishment of the WA4 Site Office and Steel Yard on Lantau Island in the new territories. This serves as the operational hub for managing various aspects of the project. Mobilization of piling rigs. To lay the foundation for the bridge, 4 BG-40 piling rigs and their necessary accessories are mobilized. These specialized rigs are crucial for drilling deep into the ground and creating stable foundations for the bridge's pillars. Hong Kong Link Road. The construction of a 9.4-kilometer viaduct with a dual 3-lane carriageway is a significant component of this project. This road segment connects Hong Kong International Airport to the Hong Kong Special Administrative Region, HKSAR boundary, facilitating smooth traffic flow to and from the airport. Installation of steel cage. The bridge's structural integrity relies on the installation of a massive 12,600-ton steel cage. This cage provides the framework for the bridge, ensuring its strength and durability. Placing of concrete. To complete the bridge's superstructure, an astounding 63,900 cubic meters of concrete are poured. The concrete is carefully placed to create the roadway and support structures, ensuring a solid foundation for the entire bridge. Pile installation. The construction team installs an impressive 3 to 4 piles each week. These piles are essential for supporting the bridge's pillars and distributing the weight of the structure evenly. Subcontract scope of works. The project's subcontractors play a vital role in various aspects of construction, including specialized tasks such as electrical work, landscaping, safety measures, and quality control. Their expertise contributes to the successful realization of this ambitious project. The Limmern Pumped Storage Plant, located in the high mountain region of Switzerland, is an impressive feat of engineering that harnesses the power of nature to generate electricity. This underground pumped storage power plant, known as Lammern, is a crucial addition to the Linth-Limmern AG power plants, operated by Axpo. With a turbine and pumping capacity of 1,000 megawatts each, this facility utilizes the height difference between two reservoirs to store and generate electricity efficiently. One of the remarkable aspects of the Limmern pumped storage plant is its challenging location. Situated in a high mountain area, the construction site is accessible only by road and rail up to a certain point. Beyond that, a cable car becomes essential due to capacity limitations. This requirement for meticulous planning and unique transportation solutions is just the beginning of the complexities involved in building this power plant. The construction process began with the excavation of a 4-kilometer-long access tunnel that led directly into the machinery cavern. This tunnel had an impressive 8-meter diameter, enabling the transport of heavy equipment into the caverns. The machinery cavern, measuring 150 meters in length and 50 meters in height, is a colossal space carved entirely out of solid rock. Excavating such a massive cavern required a combination of machinery, drilling, and blasting. The excavated material had to be carefully removed from the mountain. To facilitate the removal of excavated material, a tunnel below the caverns was employed. Most of this material was transported to the construction site for the Mutter Dam on the mountain, while the rest was processed in an underground concrete factory for use in cavern expansion. By early 2012, the excavation of the machinery cavern was completed, allowing interior work to begin. This was a tight timeline, with work simultaneously progressing in various areas. Foundations for the Francis turbine's suction pipes were prepared while sidewalls were being concreted. The vault, which previously had no support, was reinforced to withstand mountain pressure, ensuring the safety and stability of the facility. The rough construction was nearly complete by the end of 2013. Creating the sensation of being inside a mountain in some areas. Preparations for installing the technical equipment commenced, including the assembly of 2 massive overhead cranes capable of carrying 200 tons each. These cranes played a pivotal role in lowering heavy components like the Pelton turbines and motor generators into the machine shafts. Simultaneously, foundations were prepared for the machinery groups, requiring over 80,000 cubic meters of concrete, enough to build approximately 700 single-family homes. High-voltage cables were laid deep within the mountain to connect the plant to the power grid through Access Tunnel 1, which led to the tier-fed substation. From there, a new 380 kilovolt overhead power line was constructed through the Lontal, involving the erection of 53 new power line towers, some of which reached heights of up to 89 meters. Building these towers in rugged terrain was a complex task that often required helicopter transport of materials. Transporting heavy equipment to the caverns in the valley presented additional challenges. Some components, such as the spiral casing of the Pelton turbines, were too large for the standard tunnels, while the machine transformers exceeded the capacity of the 30-ton construction cable car. To overcome these challenges, Access Tunnel 1 was enlarged and equipped with a 200-ton funicular to transport these large and heavy components directly to the caverns. The machine transformers played a crucial role in converting medium voltage from the motor generators into low-loss, high voltage suitable for transport in gas-insulated switchgear. These transformers could be individually connected to the outgoing lines leading down the valley. The assembly of the machine groups was a meticulous process, with the spiral casings designed to withstand the immense forces of the water from the pressure shafts. These casings were fully embedded in concrete, and the Pelton turbine runner would rotate within them. By November 2015, the first two machine groups were successfully installed and synchronized with the power grid. The construction of the remaining machine groups was underway. Simultaneously with the expansion of the machine shafts, the movable parts of the motor generators were constructed. These rotors, weighing around 330 tons each, were too heavy to transport via the cable car and had to be assembled within the cavern. The stationary part of the motor generators, the stator, was installed above the Pelton turbines in the machine shaft. The combination of the rotor and stator would generate the power equivalent to approximately 3,000 cars in operation. The construction also involved the creation of pressure shafts leading towards the mutter reservoir. These shafts were constructed one after the other using a tunnel boring machine, featuring a steep incline of 40 degrees. These shafts terminated at the 600 meters higher Schiebekammer, where the upper water pressure tunnel and water lock were also built. The installation of 2 kilometers of armor to protect the shafts was a labor-intensive process, with steel pipes transported using temporary rails. The upper water pressure tunnel, with an impressive 8-meter diameter, connected the shifter chamber to the upper chamber, essentially acting as a large road tunnel for water. The tunnel walls were concreted using a staggered bar technique, and inlet and outlet structures were constructed at the tunnel entrance in 2012 and 2013. In 2015, the structure was nearly complete, allowing water to flow through the upper water pressure tunnel to the turbines. 2 underwater pressure tunnels to the bottom reservoir were also created from the central cavern. With the completion of all the tunnels and shafts for the pumped storage system, the construction of the inlet and outlet structures for the dam began. The Limmern Sea was mostly drained to facilitate the construction of these structures, which would allow up to 200 cubic meters of water per second to flow through. The design of these structures aimed to minimize turbulent water flow. The Oxen Stephanie, situated above the normally filled lake, served as a material handling area with crushers. It processed the excavation material from the distant world and prepared it for transport to the dam construction site. Due to the expectation of heavy snowfall in the winter, the solid buildings and cable car were protected by a dam. All excavation materials and construction machinery had to be transported from this area using construction cable car 2, which could carry up to 30 tons. This cable car led to the construction site of the Mutter Dam, located at an altitude of 2,500 meters on the Mutter. Construction activities were limited to the summer months due to the high altitude. The Mutter Dam was a significant structure, consisting of 68 blocks, each 15 meters wide. The entire dam spanned a length of 1,000 meters and took 3 summers to construct. This impressive structure serves as a crucial component of the Limmern pumped storage plant, allowing for the efficient storage and generation of electricity.
The Marshalltown Shockwave Power Screed stands out as a pinnacle of innovation and efficiency in the realm of concrete finishing equipment. Meticulously crafted with the insights gleaned from contractor feedback, the Shockwave embodies a synthesis of sought-after features, culminating in a powerhouse tool that elevates both performance and user experience. At the heart of the Shockwave lies the formidable GX35 Honda 4-stroke engine, renowned for its reliability and robust performance. This engine, with its 1.5 horsepower output, serves as the beating heart of the screed, driving its operations with unwavering precision. One of the standout features of the Shockwave is its fully adjustable handlebars and grips, meticulously engineered to cater to the individual preferences and comfort of operators. By simply loosening the hex bolts, users can effortlessly customize the height and orientation of the handlebars, ensuring optimal ergonomics for prolonged use. Moreover, the versatility extends to the handle grips, which can be adjusted in various dimensions, offering unparalleled comfort and control during operation. The exterior frame of the Shockwave is not merely a protective shell, but a dual-functional component that enhances usability. Serving as a shield for the motor, it also facilitates effortless lifting and transportation thanks to its ergonomic design. The inclusion of an L-shaped handle further streamlines handling, allowing operators to maneuver the screed with ease, even in challenging conditions. Maintenance and servicing are simplified with thoughtful design elements incorporated into the Shockwave. The accessibility of oil and fuel reservoirs, coupled with the straightforward layout, ensures expedited procedures without compromising on efficacy. The unit's lightweight construction enables it to effortlessly glide over concrete surfaces, making it an ideal companion for a myriad of applications, from street paving to form screening. The heart of the Shockwave lies in its vibration mechanism, meticulously engineered to deliver unparalleled concrete consolidation. The straight drive shaft, in perfect alignment with the engine and weights, ensures uniform vibration distribution across the blade surface. This results in superior consolidation, effectively pushing aggregate downward while allowing the cream to rise, ultimately yielding a stronger and more resilient slab. Furthermore, the Shockwave sets itself apart with its innovative throttle lever, inspired by power trowel designs. This intuitive feature eliminates the need for constant operator intervention, enabling seamless adjustments with unparalleled ease. The inclusion of a tachometer further enhances functionality, providing invaluable insights into maintenance schedules and ensuring optimal performance over the long term. The Marshalltown Shockwave Power Screed offers an extensive range of blade sizes to accommodate various project requirements and preferences. With 7 different blade lengths available, contractors have unparalleled flexibility in selecting the optimal size for their specific needs. From the expansive 16-foot blade, capable of covering vast swaths of concrete in a single pass, to the nimble 4-foot blade, ideal for intricate and confined spaces, each size serves a distinct purpose. Whether it's a large-scale paving project or intricate formwork, the Shockwave's array of blade sizes ensures that contractors can achieve precise and efficient results across a diverse range of applications. Suitable for a wide range of road surfaces, from small residential areas to major trunk routes, Colas provides a comprehensive solution tailored to the specific needs of their clients. By working closely with local authorities, they ensure cost-effective and practical solutions for road networks. Their range of plant and equipment, including machines ranging from 2 to 12 cubic meters, enables them to efficiently combine materials on-site and apply them to the surface in question. One of the key advantages of microsurfacing is its minimal preparation requirements. With thorough sweeping to remove loose materials and protection of street furniture and gullies, the process minimizes disruptions to the surrounding environment. Additionally, Cola's use of high PSV aggregate enhances skid resistance and durability, ensuring safety and longevity. The proficiency of Cola's operatives, all holding NVQs in microsurfacing, ensures precise application of the product, reducing the need for manual intervention. Furthermore, the rapid installation process minimizes disruption to road users and residents, with roads typically ready for use within 15 minutes of completion. COLA's in-house traffic management ensures safety during the process while keeping the road open to the public. Microsurfacing provides excellent adhesion to various surfaces and quickly becomes resistant to rain and traffic, offering enhanced durability and a uniform finish. Its design reduces noise levels compared to traditional surfacing, along with improved appearance and skid resistance. By forming a protective sealant over the existing surface, it prevents water ingress, further enhancing its longevity and performance. Despite its advanced features, microsurfacing offers excellent value for money compared to conventional methods, crucial for authorities facing budget constraints. COLA's backs their products with a full 2-year maintenance warranty, ensuring long-term satisfaction and performance. This approach has been successfully applied across diverse settings, from residential estates to major highways like the A1M, showcasing its versatility and effectiveness. The installation of the Hume-Deck modular bridge in Gympie, Queensland, marked a significant advancement in infrastructure development, particularly in flood-prone areas like Drummond Drive. Designed to withstand Q100 flood levels, this project demanded a robust and adaptable solution, making the Hume-Deck system the ideal choice. The Hume-Deck modular bridge installation commenced with planning, considering the unique challenges posed by the site's conditions and the need for structural integrity. At the heart of the Hume-Deck system is the innovative Hume Slab decking technology, which seamlessly integrates precast concrete panels with in-situ concrete topping. This hybrid approach not only ensures durability but also offers cost-effectiveness without compromising on quality. Precast panels, ranging from 55 mm to 100 mm in thickness, form the foundation of the bridge deck. These panels, incorporating bottom steel and engineered steel trusses, were strategically positioned to optimize spans between temporary props. With lengths capped at 12 meters to ease transportation logistics, each panel was crafted to accommodate varied designs, shapes, penetrations, and cast-in fittings. In tandem with the Hume Slab system, the Hume Span decking solution played a pivotal role, offering a lightweight alternative for commercial applications. By utilizing lightweight concrete and polystyrene void formers, the Hume Span system expedited construction while enhancing thermal efficiency, thereby reducing the need for extensive ducting requirements for air conditioning. The integration of penetrations and ducts into the mold and void design showcased the system's adaptability and versatility, ensuring seamless installation even in complex scenarios. Concrete beams, 230 mm wide by 50 mm thick, equipped with standard Hume slab trusses and polystyrene T-blocks, formed the core components of the Hume Span system, tailored to meet the specific demands of the Gympie project. As the installation progressed, attention was paid to detail, ensuring that each component seamlessly fit into place, ready to withstand the rigors of both natural elements and heavy-duty usage. The underside of the slab, left off-form, presented a blank canvas for future painting, enhancing both aesthetics and durability. Throughout the installation process, the collaborative effort of engineers, contractors, and stakeholders ensured smooth progress, overcoming challenges with ingenuity and expertise. From site preparation to final finishing touches, every step adhered to stringent quality standards, guaranteeing a bridge that not only met but exceeded expectations. Upon completion, the Hume-Deck modular bridge stood as a testament to innovation and resilience, serving as a lifeline for the community of Gympie, ensuring safe passage even in the face of adversity. With its robust design, adaptability, and cost-effectiveness, the Hume-Deck system had not only transformed infrastructure development in flood-prone regions, but had also set a new standard for excellence in bridge construction. At Heath Farm in Norwich, witness our team employing a revolutionary machine to lay curbs with unparalleled efficiency and precision. This innovative method, designed for optimal speed and safety, drastically reduces the need for manual labor, minimizing strain and enhancing productivity. The machine operates with remarkable swiftness, seamlessly placing curbs with exactitude along designated pathways and edges. Its ingenious design incorporates advanced technology to streamline the process, ensuring consistent results while significantly expediting the construction timeline. This groundbreaking approach not only accelerates the completion of projects, but also upholds stringent quality standards, guaranteeing durable and aesthetically pleasing outcomes. Nestled within the historic grounds of the old steelworks, this ambitious endeavor encompasses the establishment of vital infrastructure for a sprawling housing development. The scope of work spans an impressive array of components, including the construction of over 2 kilometers of new roads and footways, as well as the implementation of more than 4 kilometers of storm and foul drainage networks. One of the standout features of this project is the installation of a sizable culvert, comprising 2 robust 1,800 mm pipes. This critical component serves as a pivotal link in the site's drainage system, ensuring efficient water management throughout the development. The installation process, captured in a captivating time-lapse video, showcases the precision and coordinated effort required to seamlessly integrate such a significant structure into the landscape. Additionally, to enhance sustainability and minimize environmental impact, innovative practices were employed throughout the project. Notably, the use of incinerator bottom ash, IBAA, as an approved material by Northamptonshire Council for Road Construction demonstrates a commitment to resource efficiency and responsible waste management. Furthermore, on-site production of limestone 6F2 material for use as capping material underscores a dedication to utilizing locally sourced resources wherever feasible. In line with a focus on sustainability, the adoption of a solar pod generator to power site cabins represents a commendable initiative to reduce carbon usage and fuel costs. By harnessing renewable energy sources, such as solar power, the project significantly reduces its environmental footprint while simultaneously realizing substantial savings in operational expenses. The Panjnid Barrage, situated on the Chenab River, marks the culmination of the river's journey downstream of the confluence point of the Sutlej and Chenab rivers. Located approximately 13 kilometers southeast of Alipur Tehsil, district Muzaffargarh, along the Alipur-Uch Sharif Road, the Panjnid Barrage plays a crucial role in the irrigation system, supplying water to vast agricultural areas through 6 main canals. This infrastructure is integral to sustaining the livelihoods of millions of people who depend on agriculture for their economic well-being. The Trimu and Panjnid Barrages Project, TPBP, emerges as a pivotal initiative aimed at rehabilitating and upgrading both the Trimu and Panjnid barrages on the Chenab River. These barrages collectively irrigate an extensive 1.74 million hectares of agricultural land. The multifaceted objectives of the project encompass the rehabilitation and enhancement of the barrages infrastructure, along with building institutional capacity in flood risk management. Rehabilitation of Trimu Barrage. The Trimu Barrage, positioned downstream of the confluence of the Jhelum and Chenab rivers, has faced a reduction in its flood passing capacity, FPC, over time. Originally designed to accommodate 18,265 cubic meters per second, M3's 1, its FPC has diminished to 12,743 meters 3s1. The TPBP addresses this challenge by undertaking comprehensive rehabilitation measures to augment the FPC to an impressive 23,220 meters 3s1. This enhancement ensures the barrage's resilience to increased water flows, a critical factor in managing seasonal variations and potential flooding. Downstream of the confluence point of the Sutlej and Chenab rivers lies the Panjnid Barrage. This essential infrastructure has also experienced a decline in its original flood passing capacity, dropping from 19,822 meters 3s-1 to 24,495 meters 3s1. The TPBP endeavors to reverse this trend by rehabilitating the Panjnid Barrage and augmenting its FPC. The project's interventions aim to enhance the barrage's capability to withstand and manage higher water volumes efficiently. The rehabilitation and upgrading of Trimu and Panjnid barrages are of paramount importance for several reasons. Firstly, these barrages are integral components of the irrigation system, providing water to an extensive agricultural landscape. The enhanced FPC ensures a more reliable and efficient water supply for farming, contributing to increased agricultural productivity and livelihood sustainability. Secondly, the project addresses the imperative need for strengthening flood risk management. With climate change and unpredictable weather patterns, the frequency and intensity of floods have become more pronounced. By augmenting the FPC of both barrages, the TPBP plays a crucial role in fortifying the region's resilience against potential flooding, safeguarding lives, property, and agricultural resources. The TPBP not only focuses on physical infrastructure improvements, but also places a significant emphasis on building institutional capacity in flood risk management. This involves training and equipping relevant authorities with the necessary skills and knowledge to respond effectively to flood-related challenges. Strengthening institutional capacity is essential for long-term sustainability and adaptive management in the face of evolving environmental conditions. Superpassage Road 1393+987 is a crucial transport link, seamlessly connecting regions with a smooth flow, enhancing accessibility and facilitating efficient travel. It's a vital infrastructure artery. Lining from RD 1301+400 to RD 1304+850 improves water conveyance, enhancing irrigation efficiency. This crucial infrastructure upgrade optimizes resource utilization for agricultural development. Slope trimming at RD 1305+750 ensures stability, reducing erosion risks and enhancing road safety in challenging terrains. Earthwork at RD 1299+750 involves excavation and embankment, reshaping the terrain for infrastructure projects. Precision ensures stability, drainage, and project success. Canal lining at RD 1306+250 involves the application of impermeable materials, reducing water seepage. This enhances water conservation, improves irrigation efficiency, and sustains agricultural productivity in the region. The wing wall at RD 1295+440 fortifies canal infrastructure, preventing erosion and ensuring stable water flow, crucial for effective water distribution in the distribution system. The earthwork from RD 1312+000 to RD 1307+000 involves excavation and embankment, reshaping the terrain to accommodate infrastructure needs. precision in leveling and compaction ensures stability, while proper drainage design minimizes erosion risks, contributing to the overall success and sustainability of the construction project. Canal lining, observed from RD 1301 plus 400 to RD 1304 plus 850, enhances water efficiency, reducing seepage for improved irrigation.